Hello, namaskara ಎಲ್ಲರಿಗೂ. Welcome you all to the Vedanta Karnataka. ನಾನು ನಿಮ್ಮ ಮಾಸ್ಟರ್ ಟೀಚರ್ Rithika Ma'am. ಸೊ ಇವತ್ತಿನ ಚಾಪ್ಟರ್ ಯಾವುದಪ್ಪ? ಸೊಲ್ಯೂಷನ್. ಓಕೆ, ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಇಂದ KCET-ಗೆ ಯಾವ ತರ ಮಾರ್ಕ್ಸ್ ಬೀಳುತ್ತೆ ಮತ್ತೆ ಎಷ್ಟು ಹೈ ವೇಟೇಜ್ ಇದೆ ಅನ್ನೋದು ಫಸ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ, ಆಯ್ತಾ? ಸೊ ಫಸ್ಟ್ ಟೆಲ್ ಮಿ, am I audible and visible properly to everyone? Am I audible and visible properly to everyone? ಸರಿಯಾಗಿ audible ಇದೆನಾ? Am I audible and visible properly to everyone properly? Let me check once. Yes. Okay, then let's start the class. Okay, ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಇಂದ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಬೀಳುತ್ತೆ? ಓಕೆ, ಆಕ್ಚುಲಿ KCET ಪರ್ಸ್ಪೆಕ್ಟಿವ್ ಇಂದ ನೋಡಿದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ಸ್ ಇಂದ ಮೀನ್ಸ್ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ. ಓಕೆ, ಫಿಕ್ಸ್ಡ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ. ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂದ ಶಾರ್ಟ್ ಆಗಿ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ ಅವು. ಓಕೆ, ಸೊ ಅವ್ನು ಬಿಟ್ಟು ಬೇರೆ ಯಾವ್ದಾದ್ರು ಇದ್ರೆ ಇಟ್ಸ್ ಲೈಕ್ ವಿ ನೀಡ್ ಟು ಚೆಕ್ ಇಟ್ ಔಟ್. ಓಕೆ, ಬಟ್ ಅದು ಶಾರ್ಟು ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂದ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಅದನ್ನ ಬಿಟ್ಟು ಯಾವ್ಯಾವ ಬೇರೆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆಯಲ್ಲ ಅದ್ರಲ್ಲಿನೂ ಬೀಳ್ಬೋದು. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಬೇರೆದ್ರೆಲ್ಲ ಕೇಳಲ್ಲ ಅಂತ, ಬಿಕಾಸ್ ನಾನಂತ ಕ್ವಶನ್ ಪೇಪರ್ ಮಾಡ್ತಿಲ್ಲ, ಅವರೇ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಅವ್ರಿಗೆ ಗೊತ್ತಿರೋದಲ್ಲ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಇಟ್ಸ್ ಅ ಟೈ. ಓಕೆ, ಸೊ ಬಟ್ ಫಿಕ್ಸ್ಡ್ ಆಗಿ ಒಂದು ಸ್ವಲ್ಪ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಂತ ಶಾರ್ಟ್ ಬೀಳತ್ತೆ. ಅವನ್ನೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಇವತ್ತು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ, ಆಯ್ತಾ? ಸೊ ವಾಟ್ ಟೈಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್, ಹೌ ಮಚ್ ಕ್ವಶನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್, ಫಸ್ಟ್ ಲೆಟ್ ಮೀ ಟೆಲ್ ಯು ಪೀಪಲ್. ಓಕೆ, ಎಷ್ಟು ಬೀಳ್ಬಹುದು ಅನ್ನೋದು ನಿಮಗೆ ಫಸ್ಟ್ ಹೇಳ್ತೇನೆ. ಸೊ ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಯು ಮೈಟ್ ಗೆಟ್ ಇಟ್ ಅರೌಂಡ್ 3 to 4 questions. Clear? Means you will get 3 to 4 marks also from that. Okay, 3 to 4 marks ಬೀಳ್ಬೋದು. 4ಕ್ಕಿಂತ ಜಾಸ್ತಿನೂ ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು ಈ ಚಾಪ್ಟರ್ ಇಂದ, ಆಯ್ತಾ? ಅಂಡ್ ಮೇನ್ ಥಿಂಗ್ ಈಸ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಸಮ್ ಪೀಪಲ್ ಫೀಲ್ಸ್ ಇಟ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್, ಸಮ್ ಪೀಪಲ್ ಫೀಲ್ಸ್ ಇಟ್ ಲೈಕ್ ವೆರಿ ಮಚ್ ಈಸಿ. ಓಕೆ, hi everyone. Yes. So some people will feel it very difficult this chapter, some people will feel it like very easy. Okay, ಎಷ್ಟು ಮಂದಿ ಈಸಿ ಆಗ್ತಿದೆ ಅವ್ರು ಫಾಸ್ಟ್ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹೇಳಿ ನೋಡೋಣ. ಸೊ ಯಾರಿಗೆ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತಿದೆ ಅಲ್ಲ ಅವ್ರಿಗೆ ಇದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಸರಿಯಾಗಿ ಆಗಿಲ್ಲ. ಓಕೆ, ಯಾಕಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಜಾಸ್ತಿ ಇದೆ. ಓಕೆ, ಐ ಅಗ್ರಿ ದಟ್ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದೆ ಈ ಚಾಪ್ಟರ್ ಇಂದ, ರೈಟ್? ಬಟ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್ ಹಿಯರ್. ಒನ್ ಸೆಕೆಂಡ್ ಗೈಸ್. ಓಕೆ, ಸೊ ಈ ಚಾಪ್ಟರ್ ಇಂದ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತೂ ಜಾಸ್ತಿ ಇದೆ, ಅದಕ್ಕೆ ಆ ತರ ಟೈಪ್ಸ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಬಹಳ ಕೇಳ್ತಾರೆ, ಆಯ್ತಾ? ಸೊ ಮತ್ತೆ ಥಿಯರಾಟಿಕಲ್ ಕ್ವಶನ್ಸ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಈ ಚಾಪ್ಟರ್ ಇಂದ, ಬಿಕಾಸ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ ಮೋರ್ ಅಬೌಟ್ ದ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇಟ್ ಸೆಲ್ಫ್. ಓಕೆ, ಸೊ ಇವತ್ತು ಏನೇನ್ ತರ ಮಾಡೋಣ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇನೆ. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ನೋ, ಬಟ್ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ಸಮ್ ಆಫ್ ದ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಫಸ್ಟ್ ಅಂಡ್ ದೆನ್ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದ ಕ್ವಶನ್ಸ್. ಓಕೆ, ಫಸ್ಟ್ ಫುಲ್ ಥಿಯರಿ ಪರ್ಫೆಕ್ಟ್ ಆಗಬೇಕು. ಥಿಯರಿ ಪರ್ಫೆಕ್ಟ್ ಆಗಲ್ದ ಹೋಗಿ PYQ ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ ಅಂದ್ರೆ ಇಟ್ಸ್ ಆಫ್ ನೋ ಯೂಸ್. ಓಕೆ, PYQ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. KCET PYQ ಸಾಲ್ವ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಏನೂ ಉಪಯೋಗ ಇಲ್ಲ, ಐ ಅಗ್ರಿ. ಬಟ್ ಇಫ್ ಇನ್ ಕೇಸ್ ಯು ಆರ್ ನಾಟ್ ಸಾಲ್ವಿಂಗ್ ಫಸ್ಟ್ ದ ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಇಲ್ಲ ಅಂದ್ರೆ ಥಿಯರಿ PYQ ಸಾಲ್ವ್ ಮಾಡೋದು ಮುಂದೆ ನಿಮಗೆ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ, ಆಯ್ತಾ? ಸೊ ಫಸ್ಟ್ ಅದಕ್ಕೆ ಬೇಸಿಕ್ ಇಂದ ಹೋಗ್ಬೇಕು, ಬೇಸಿಕ್ ಮುಗಿಸ್ಬೇಕು ಲೆಸನ್ ಅನ್ನ, ಆಮೇಲೆ NCERT ಫುಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಮುಗಿಸ್ಬೇಕು. ಅದಕ್ಕೆ ಇವತ್ತು ನಾ NCERT ದಿಂದಾನು ಸ್ವಲ್ಪ ತಗೊಂಡಿದ್ದೇನೆ, ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಸೊ ಅದಾದ ತಕ್ಷಣ ನೀವು ಈಸಿ ಮಾಡಬೇಕು, ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಮಾಡಬೇಕು. ನಾನು ನಿಮಗೆ ಸ್ವಲ್ಪ ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ತಂದಿದ್ದೇನೆ. ಸೊ ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಮಾಡಿದ್ರೆ ಈಸಿ ಆಗುತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗು, ಆಯ್ತಾ? ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ಇಟ್. First about the solution. So it is a homogeneous mixture of two or more chemically. It is a homogeneous mixture of two or more chemically non-reacting substances. Chemically non-reacting substances. Non-reacting substances whose composition can be changed within the certain limits. So ಯಾವ್ದು homologous mixture ಅಂದ್ರೆ ಏನು? It is a two or more chemically non-reacting. ಎರಡು chemicals ಇದೆ but they are not reacting to each other. Okay, and those composition can be changed within the certain limits. Okay, certain limits ನಲ್ಲಿ ಅದರದ್ದು composition ಪೂರ್ತಿ change ಮಾಡ್ಕೋಬಹುದು, ಆಯ್ತಾ? Next, the solution is regarded as a singular phase having more than one component. It's having actually actually more than one component. Clear? So the solution which contains the two components is known as binary solution. So it's actually known as what? Binary solution. Means what? A solution which is containing only two components. It's actually containing only two components is called as binary solution. Then the component which is present in the smaller quantity is called as a solute, and which is having a more quantity, the larger quantity, is called as a solvent. So simple examples also will take for the solute and solvent. So solute matte solvent. Yes, understanding everyone? ತಿಳಿದಿದ್ದೇನಲ್ಲ? So solute ಯಾವ್ದಪ್ಪ ಮತ್ತೆ solvent ಯಾವುದು? Solute is always in a smaller quantity and solvent is always in a more quantity. Okay. Sorry. Okay. ನಾನು ಈಗ ಒಂದು glass of water ತಗೊಂಡಿದ್ದೀನಿ. Okay. I have taken a water of a glass or a glass of a water. Yes, ma'am, the English ಏನೇನಾಗ್ತಿದೆ ನೋಡಿ. So water of a glass of water, I have taken it. In a glass of water, I have added some particles of salt in it. Okay, I have added some particles of salt in it. Now you people need to tell me here what is going to be the solute. Solute will be the salt which we have added, like NaCl, and this will be the water, like solvent will be the water. It means what? Always the solvent will be in the more quantity and the solute will be in the lesser quantity. Yes, this is the easiest thing. You people have learned it, I know, but also I'm repeating it because some students will feel it a little bit confusing, so I just clarified it. Okay. Next comes what? Solute, solvent, and examples also they have given in a very simple way to make you understand. Okay. Solid and renu, solid is actually if in case, okay. We have taken solute as a solid, solvent has a solid. Okay. ನಾನೀಗ ಏನು ತಗೊಂಡಿದ್ದೆ, ಬಟ್ ಇದರಲ್ಲಿ ಒಂದು ಸೊಲ್ಯೂಟು ಆಕ್ಚುಲಿ ಸಾಲಿಡ್ ತಗೊಂಡಿದ್ದೆ, ಸಾಲ್ವೆಂಟು ನೀರನ್ನು ತಗೊಂಡಿದ್ದೆ, ರೈಟ್, ವಾಟರ್ನ ತಗೊಂಡಿದ್ದೆ, ಲಿಕ್ವಿಡ್ ಇಟ್ ಇಸ್, ರೈಟ್. ಬಟ್ ಹಿಯರ್ ವಾಟ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಸೊಲ್ಯೂಟ್ ಆಸ್ ಅ ಸಾಲಿಡ್ and a solvent has a solid itself. Clear? So what will be the example? We can give it as alloys or stones. Alloy or stones, where the solid will combine together to form a alloys or stones. Sorry. Okay? Clear? Yes? Understanding? Yes? Very good. Yes, next comes what? Solid and liquid. So solute in tondidare solid matte solvent liquid. Just now I took example, no, that example also we can take it. Okay, sugar, salt in a water, sugar which we are adding it in the salt in a water. Clear? Next comes what? Solid and gas. So solid and gas tale iodine vapors in the air. So iodine vapors which are there, that vapors in the air, that is actually called as what? Solid will be the iodine. Clear? The solvent will act like a gas, that is vapors in the air. Done. So in this way you have given few more further examples to you people, like liquid and solid, liquid and liquid, liquid and gas, gas and solid, gas and liquid, gas and gas. So these examples also according to that they have given it. Clear? So ಇಲ್ಲಿ ಏನು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಅಂದ್ರೆ ಯಾವ ಸೊಲ್ಯೂಟು ಯಾವ ಸಾಲ್ವೆಂಟು ಯಾವ ತರ ಮಿಕ್ಸ್ಚರ್ ಆಗ್ತಿದೆ. ಓಕೆ, ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಮೇನ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಅಂದ್ರೆ ಏನಿದೆ, ಆಕ್ಚುಲಿ ಸೊಲ್ಯೂಟು ಸಾಲ್ವೆಂಟ್ ನಲ್ಲಿ ಯಾವ ತರ ಮಿಕ್ಸ್ ಆಗ್ತಿದೆ. Okay, so ಆಮೇಲೆ if in case you're heating it up, what type of vapors are coming, at what temperature you're heating it, at what pressure you're applying there, so at what temperature and pressure the solution is getting heated. So those all things you will calculate it. ಓಕೆ, ಸೊ ಈಗಿನ ತನಕ ನೀವು ಏನು ಮಾಡ್ತಿದ್ರಿ, ಓಕೆ ಬರೇ ಒಂದು ನೀರು ಹಿಟ್ ಮಾಡಿದ್ವು, ಉಪ್ಪು ಹಾಕಿದ್ವಿ, ನೀರು ಹಿಟ್ ಮಾಡಿದ್ವು, ಅದನ್ನೆಲ್ಲ ಕಲ್ತ್ರಿ ನೀವು. ಓಕೆ, ಬಟ್ ಇದರಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಲೈಕ್ ಅ ಡಿಫ್ರೆಂಟ್ ಥಿಂಗ್ ಓನ್ಲಿ. ಸೊ ಯಾವ ಟೆಂಪ್ರೇಚರ್ ಮ್ಯಾಮ್, ಎಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಕೊಟ್ಟಿದ್ದೀರಾ ಆ ಸೊಲ್ಯೂಷನ್ಗೆ ಬಾಯ್ಲ್ ಆಗಲಿಕ್ಕೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಯಾವ ತರ ನೀವು ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀರಾ, ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್. ಈಗ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ಅಂದ್ರೆ ನಿಮ್ಮ ಮಮ್ಮಿ ಕುಕ್ಕರ್ ಇಡ್ತಾಳಪ್ಪ, Okay, so ನಿಮ್ಮ ಮಮ್ಮಿ ಕುಕ್ಕರ್ ಇಟ್ಟಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, it is a closed container. Cooker, rice is getting boiled inside the cooker. ರೈಸ್ ಎಲ್ಲಿ ಆಗ್ತಿದೆ, ಅನ್ನ ಎಲ್ಲಿ ಆಗ್ತಿದೆ, ಅದು ಕುಕ್ಕರ್ ನಲ್ಲಿ ಆಗ್ತಿದೆ. ಕುಕ್ಕರ್ ನಲ್ಲಿ ಕಂಪ್ಲೀಟ್ಲಿ ನಾವು ಪ್ಯಾಕ್ ಮಾಡಿದ್ದೇವೆ, ಕುಕ್ಕರ್ ನಲ್ಲಿ ಹಾಕಿದ್ದೇವೆ. ನಾವು ವಾಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್, ವಿ ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ಅ ಪ್ರೆಷರ್ ದೇರ್. ಏನ್ ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು, ಪ್ರೆಷರ್. ದಟ್ ಇಸ್ ವಾಟ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ರೆಷರ್ ಕುಕ್ಕರ್. ಏನ್ ಕರೀತಾರೆ ಅದಕ್ಕೆ, ಹೆಸರೇನಿದೆ ಅದರದ್ದು, ಪ್ರೆಷರ್ ಕುಕ್ಕರ್. ನಾವು ಏನ್ ಮಾಡ್ತಿದ್ದೇವೆ, ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಕೆಮಿಸ್ಟ್ರಿ ಗೈಸ್. ಸೊ ಈಗ ಅದರಲ್ಲಿ ನಾವು ನೀರ್ ಹಾಕಿದ್ವಿ ಅಪ್ಪ, ರೈಸ್ ಹಾಕಿದ್ವಿ, ಉಪ್ಪು ಹಾಕ್ಸಿದ್ವಿ, ಸ್ವಲ್ಪ ಒಂದ್ ಸ್ಪೂನ್ ಆಯಿಲ್ ಹಾಕಿದ್ವಿ, ರೈಟ್. ಸೊ ನಾ ಈಗ ನಮ್ಮ ಮ್ಯಾಮ್ ಅಂತೂ ರೈಸ್ ರೆಸಿಪಿ ಹೇಳ್ತಿದ್ದಾರೆ ಅಂತ ಹೇಳ್ಬೇಡಿ. ಸೊ ದಿಸ್ ಇಸ್ chemistry which I am relating and telling you people that what you people will learn in this chapter. Okay, so ಅದರಲ್ಲಿ ರೈಸ್ ಹಾಕಿದ್ವಿ, ನೀರ್ ಹಾಕಿದ್ವಿ, ಉಪ್ಪು ಹಾಕಿದ್ವಿ, ಸ್ವಲ್ಪ ಆಯಿಲ್ ಹಾಕಿ ಮಿಕ್ಸ್ ಮಾಡಿ ಆಮೇಲೆ ನಾವು ಕುಕ್ಕರ್ ಪ್ಯಾಕ್ ಮಾಡಿ ಸೀಟಿ ಹಾಕಿ ಗ್ಯಾಸ್ ಮೇಲೆ ಇಟ್ಟಿದ್ವಪ್ಪ. ಓಕೆ, ನಾವು ಯಾವಾಗ ಗ್ಯಾಸ್ ಮೇಲೆ ಇಡ್ತೇವಲ್ಲ, ಆ ಗ್ಯಾಸ್ ಮೇಲೆ ಇಟ್ಟಿದ ತಕ್ಷಣ ಅದು ಏನ್ ನಾವು ಟೆಂಪರೇಚರ್ ಕೊಡ್ತಿದ್ದೇವೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕೊಡಬೇಕು. ಏನಂತಾರೆ ನಿಮ್ಮ ಮಮ್ಮಿ, ಫುಲ್ ಜೋರಾದ್ರೂ ಇಡು, ಫುಲ್ ಸಣ್ಣಾದ್ರೂ ಇಡು. ಓಕೆ, ಇಲ್ಲಾಂದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ ಮೀಡಿಯಂ ಆದ್ರೂ ಇಡು, ಬಟ್ ಡೋಂಟ್ ಚೇಂಜ್ ಇಟ್ ಎವ್ರಿ 2 minutes 3 minutes ದ ಟೆಂಪರೇಚರ್. ಸೊ ಟೆಂಪರೇಚರ್ ಸೇಮ್ ಇರಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ರೈಸ್ ಸರಿ ಆಗಲ್ಲ ಅಂತ ನಿಮ್ಮ ಮಮ್ಮಿ ಹೇಳಿರ್ಬೇಕು ನಿಮಗೆ, ರೈಟ್. ಸೊ ಅದೇ ತರ ಇಲ್ಲಿನೂ ಹಾಗೆ, ಟೆಂಪರೇಚರ್ ಶುಡ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್. ಸಮಟೈಮ್ಸ್ ಟೆಂಪರೇಚರ್ ಇಫ್ ಯು ಆರ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಇಟ್, ದೇರ್ ಮೈಟ್ ಬಿ ಅ ಚೇಂಜಸ್ ಇನ್ ದ ಸೊಲ್ಯೂಷನ್. ಕ್ಲಿಯರ್? ಸೊ ಅದೇ ತರ ಇಲ್ಲಿ ಪ್ರೆಷರ್ ಕುಕ್ಕರ್ ನಲ್ಲಿಯೂ ಆಗುತ್ತೆ. ದೇರ್ ವಾಟ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್, ದೇರ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಪ್ರೆಷರ್, you are applying the temperature, you are applying already the temperature, but pressure will be created inside. Same way it in a closed container what is happening, in an open container what is happening, that all details we will study with the chemicals in this chapter. Okay, so ella chemical idralla ee chapter nalli kaliyodu aita. So next comes the types of solution, like solution of a solids and liquids. It is a solution which still it is a solution which still in a contact with the excess of solute. So what is a solution of a solid in liquid? Okay, solutions of solid in liquid andre liquid nalli solid anna haktidave. Liquid is acting like a solvent, we are adding the solute inside it. Clear? So now the solubility of the solute is defined as the amount of the solute dissolved per 100 gram of the solvent. Per 100 gram of the solvent, yes, the amount of the solute, a solute per 100 gram jode ಎಷ್ಟಪ್ಪ dissolve ಆಗುತ್ತೆ, how much time it is taking, ಎಷ್ಟು ಡಿಸಾಲ್ವ್ ಆಗಿದೆ, ಕ್ವಾಂಟಿಟಿ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅಲ್ಲ. ಈಗ ನಾ 1 kg ಉಪ್ಪ ಇಲ್ಲಾಂದ್ರೆ ಶುಗರ್ ತಗೊಂಡು ನಾ ಹೋಗಿ ನೀರ್ನಲ್ಲಿ ಹಾಕ್ತೇನೆ, 1 ಲೀಟರ್ ನೀರಲ್ಲಿ ಹಾಕ್ತೇನೆ ಅಂದ್ರೆ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತಾ, ಇಲ್ಲಲ್ಲ. ಸೊ ಇಟ್ ನೀಡ್ಸ್ ವಾಟ್, ಇಫ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ 1 kg then the water also quantity needs to be increased, right? That is very important, right? It's not like I'm telling, na ಹೇಳ್ತಿದ್ದೇನೆ ಈಗ ನಿಮ್ಗೆ ಉಪ್ಪು ನೀರಿನಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಿದ್ದೇನೆ. It's not like I'm adding ಈ 1 ಗ್ಲಾಸ್ ನೀರಿನಲ್ಲಿ 1 kg ಫುಲ್ ಉಪ್ಪು ಹಾಕಿದ್ನೆಪ್ಪ, ಶುಗರ್ ಹಾಕಿದ್ನೆ ಅಂದ್ರೆ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತಾ, ಇಲ್ಲಲ್ಲ. There the quantity also matters a lot. Okay, that's why the amount of the solute which is dissolved, how much amount of the solute is being dissolved per 100 gram of solvent, means per 100 gram of solvent ಎಷ್ಟಪ್ಪ solute dissolve ಆಗ್ತಿದೆ, that at a specific temperature. So we are applying a temperature to dissolve also, right? So at a specific temperature for a saturated solution, for a saturated solution. Clear? For exothermic substances such as KOH, CaO, CaOH2 and M2CO3 and M2SO4 etc. exothermic substances ಗಳು ಆಗಬಹುದು ಆಯ್ತಾ. Next, 1 second guys. Solubility is inversely proportional to this temperature. So solubility is actually inversely proportional to the temperature. It means what, main important concept is what here, what you need to remember, whatever the solubility is there, that solubility is inversely proportional to the temperature. You people need to remember this concept. Clear? Okay, ಇದನ್ನ ನೆನಪು ಇಟ್ಕೋಬೇಕು. ಸಿ ಏನು ಸಿಕ್ಕಾದ ಟೈಮಿಂಗ್ ತೋರಿಸುತ್ತೆ ಇಲ್ಲಿ. ಓಕೆ, so now next comes what, for endothermic substances such as NaCl, KNO3, NaNO3, glucose etc. solubility is directly proportional to the temperature. So what endothermic substances ಏನಾಗುತ್ತೆ, like NaCl, KNO3 ತಗೊಂಡ್ವಪ್ಪ, ಇಲ್ಲಾಂದ್ರೆ NaNO3 ತಗೊಂಡ್ವಿ. ಸೊ ಅವಕ್ಕೆಲ್ಲ ಏನಾಗುತ್ತೆ, solubility is directly proportional to the temperature. This is for which, ಇದು ಎದಕ್ಕಾಯ್ತು, this is for exothermic process. Okay, ಈಗ ಎಂಡೋಥರ್ಮಿಕ್ಗೆ ಏನಾಗುತ್ತೆ? For endothermic, solubility is directly proportional to the temperature. Clear? Understood? So this much you people need to remember. Clear, everyone? Next, solubility of gases. Solubility of gases is mostly described in terms of absorption coefficient, that is the volume of the gas at normal temperature pressure dissolved by unit volume of the solvent at a specific temperature and 1 atm pressure. At a specific temperature and at a 1 atm pressure. Now, the solubility factor for a gas in a liquid depends upon. So, the solubility of a factor, solubility factor, ಎಷ್ಟಪ್ಪ gas in a liquid depends upon. How much the gas of that it is going to depend upon. Okay. Now, temperature, that is solubility have a inverse relationship with the temperature, has dissolution of a gas is exothermic in most of the cases. So, gas plus liquid is going to give us what? Dissolved gas. So, gas plus liquid, we are going to get what? Dissolved gas, that is delta H is equal to always be in a negative. Delta H is going to be always be in a negative. Understanding? Yes? Clear? Next. Now next comes, first one is done, that is about the temperature. Next comes the nature of the gas. So in nature of the gas is what? The gas which can easily be liquefied are more soluble as they contain higher volume of van der Waals force of attraction. Okay. Now whatever the gas is there which can be easily liquefied, gases can be easily liquefied if in case they have a rule also there. If in case it is more soluble as they contain, if it is more soluble as they contain a higher van der Waals force. Okay. If the van der Waals force is good and higher, then a liquefied gas will completely soluble in any of the things. Okay. In any of the things. Next, for example, SO2 and CO2 are more soluble water than O2, N2 and H2. So what happens? Example, SO2 and CO2 are more soluble water than the O2, N2 and H2. Clear? So this also you should remember, important. Okay. Next comes the nature of the solvent. Yes, nature of the solvent is also very important. Okay. ಈಗ ನಾವು ಯಾವ ತರ solvent, because solvent to solution ನಲ್ಲಿ ಬಹಳ important part ಇದೆ. Okay. So it is just like how king of the lion, so king of the forest ಯಾವುದು lion, right? So king of the forest is actually lion. Same that way in a solution, solvent is also a king. Now ಯಾವ ತರ solvent ತಗೊಂಡಿದ್ದೇವೆ, like example we have taken a liquid or a gas, or in case we have taken a solid. So depends on the solvent only we can tell that whether the solution is going to be soluble completely or no, or whether it is going to act on the presence of a temperature or pressure or no. That is very important. Okay, like gases which can be ionized in aqueous solution are more soluble in the water as compared to the other solvents. Clear? Next comes pressure of the gas, that is also called as a Henry's law. So pressure of the gas is also called as Henry's law, and this is also very, very important. Okay, ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ರು ಕೇಳಬಹುದು ಹೆನ್ರೀಸ್ ಲಾ ಮೇಲೆ. ಓಕೆ, ಮೋಸ್ಟ್ ಪ್ರೊಬಬ್ಲಿ PU ಬೋರ್ಡ್ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಒನ್ ಸೆಕೆಂಡ್ ಗೈಸ್, ಮೋಸ್ಟ್ ಪ್ರೊಬಬ್ಲಿ PU ಬೋರ್ಡ್ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. PU ಬೋರ್ಡ್ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಬಟ್ KCET ಮೇಲೇನು ಕೇಳಬಹುದು ಹೆನ್ರೀಸ್ ಲಾ ಮೇಲೆ, ಮೀನ್ಸ್ ಅಪ್ಲಿಕೇಶನ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್ಸ್ ಕೇಳಬಹುದು. ಆಯ್ತಾ? ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದೆನ್. This law states that the solubility of the gas is given the volume of the liquid at constant temperature. So volume of the liquid at constant temperature means what? Now we have taken some volume. Okay, 20 ml of water you have taken it, right? So that 20 ml of volume of the liquid at a constant temperature you need to boil it, okay, is directly proportional to the pressure of the gas. So is directly proportional to what? Pressure of the gas. Concentrate properly here. ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ actually ಇದು ಏನೇನು ಆಗ್ತಿದೆ ಅಲ್ಲ volume of the liquid at constant temperature is directly proportional to ಏನೇನು ಆಗ್ತಿದೆ ಅಲ್ಲ those all things ಎಷ್ಟು ಯಾವ ತರ ನೀವು liquid ತಗೊಂಡಿದ್ದೀರಾ that is important. Okay, ಮತ್ತೆ volume ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀರಾ in case you have taken 10 ml, okay, 10 ml of water you have taken it, done. Now once you have taken the 10 ml of water, in the 10 ml of water you are constantly heating it like 298 Kelvin ತರ heat ಮಾಡ್ತಿದ್ದಾರೆ, okay, 298 ತರ heat ಮಾಡ್ತಿದ್ದಾರೆ. Now at 298 Kelvin you are heating the concept, okay, you are heating the volume. Okay, now what you need to remember here, at that time what type of a pressure is being created, at what time, that is directly proportional to the pressure which has been got created there. Okay, same ಅದೇ ತರ ಇಲ್ಲಿ, okay, directly proportional to the pressure of the gas which is being created, that is m is directly proportional to P. So in this m directly proportional to B, this proportionality constant which is there, this proportionality constant which is there, that is going to be acting like a K. That is going to act like a K. Clear? So for that purpose, m is equal to K into P. Done? Understood? This is also very important, guys. Henry's law andre eno volume of the liquid. Enen volume of the liquid ide alla, whatever the volume of the liquid is present here, whatever the volume of the liquid is present, how much ever you have taken the volume of the liquid at a constant temperature, okay, at a constant temperature. At a constant temperature, it's directly proportional to, okay, directly proportional to, it's directly going to be proportional to the pressure of the gas. Okay, then this much you people will remember. Yes, next. Now, or m divided by P is actually going to be like a KH at constant temperature. At constant temperature, how it's going to act? At constant temperature, whenever the volume of the solution divided by the pressure which is being created, that will be at a constant temperature. This will be the concept, okay, where P is the pressure of the gas at equilibrium with a solution. Yes, that's what I told you, pressure which has been creating there, and m is equal to the mass of the gas which is dissolved by the unit volume of the solvent. Unit volume of the solvent. Here KH is actually going to be what? Henry's constant. KH is going to be acting like a Henry's constant, and function of the nature of the gas is going to be, this is Henry's constant is going to be function of the nature gas. Done? KH andre Henry's constant. K andre you people know just proportionality constant. KH andre Henry's constant. Done? Don't forget the KH thing. Theta. Yes, next, when solubility is expressed as its mole fraction, that is P is directly proportional to X. If in case, okay, P is directly proportional to X or P is equal to also KHX, then solubility is inversely proportional to the Henry's law. So what happens here? So this solubility, whichever is there, solubility, okay, in solubility idella, that solubility is actually inversely proportional, okay, that is going to be inversely proportional to the Henry's constant. It's inversely proportional to the Henry's constant. Clear? Done? Yes. Now one more we need to understand according to the graph now. So according to the graph ಏನಾಗುತ್ತಪ್ಪ? Okay, ತಿಳಿತಿದ್ದೇನೆ ಎಲ್ಲರಿಗೂ? Yes. Understood? Yes. Now ಈಗ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಗ್ರಾಫ್ ಏನಾಗುತ್ತೆ, ಸೊ ಇದು ಗ್ರಾಫ್ ಇದೆ, ಸೊ ಇಲ್ಲಿ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್, ಓಕೆ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ದಿಸ್ ಇಸ್ ಇಂಟು ಪ್ರೆಷರ್ ಡಿವೈಡೆಡ್ ಬೈ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಒಂದು ಗ್ರಾಫ್ ತೆಗೆದಿದ್ದಾರೆ. ಡನ್. ಸೊ ಇನ್ ದಟ್ ಗ್ರಾಫ್ ವಾಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್ ನಾವ್ whenever that mole fraction which is there according to the pressure, that's going to always start increasing only, no? So it's going to be increasing itself. Why it's increasing? So whenever the mole fraction of the element is going to apply there, the pressure will start increasing always. See, the temperature ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ pressure ಅನ್ನು ಜಾಸ್ತಿ ಆಗೋತ್ ಹೋಗುತ್ತೆ. It's not like temperature ಕಡಿಮೆ ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ pressure ಕಡಿಮೆ ಆಗುತ್ತೆ. Pressure will be always be created only, right? So that's what the problem is about the pressure cooker also. So now actually temperature ಅಂತೂ ಹಾಕ್ತೇವೆ, but once the temperature to cool down the pressure, it will take time. ಅದಕ್ಕೆ ನಿಮ್ಮ ಅಮ್ಮ ಏನಂತಾರೆ, ನೀವು ಕುಕ್ಕರ್ ರೈಸ್ ಪ್ರಿಪೇರ್ ಮಾಡಿದ ತಕ್ಷಣ ಒಂದು 5 ನಿಮಿಷ 10 ನಿಮಿಷ ನಿಲ್ಬೇಕು ಅದನ್ನ, ಬಿಕಾಸ್ ದ ಪ್ರೆಷರ್ ವಿಚ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಕ್ರಿಯೇಟೆಡ್ ಇನ್ಸೈಡ್ ದ ಕುಕ್ಕರ್, ಏನ್ ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಆಗಿರುತ್ತಲ್ಲ ಅದು ಕೂಲ್ ಡೌನ್ ಆಗ್ಲಿಕ್ಕೆ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಅ ಟೆಂಪರೇಚರ್ ದಟ್ ಐ ಚೇಂಜ್ ಇಟ್. ಈಗ 100 ಡಿಗ್ರಿ ಹಾಕ್ತಿದ್ದೆಪ್ಪ, ಮೊನ್ನೆ 200 ಡಿಗ್ರಿ ಹಾಕಿದೆ, ಆಮೇಲೆ ಒಂದು ಸ್ವಲ್ಪ ಹೊತ್ತು ಆದ ತಕ್ಷಣ 150 ಹಾಕಿದೆ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಚೇಂಜ್ಡ್, ಬಟ್ ದ ಪ್ರೆಷರ್ ಕ್ಯಾನ್ ಬಿ ಚೇಂಜ್ಡ್ ಇಮಿಡಿಯೇಟ್ಲಿ. ಡನ್? ಕ್ಲಿಯರ್? Yes. Next, the Henry's law is obeyed only when. So when this Henry's law is going to be obeyed, that is important. Okay. ಯಾವಾಗ ಇದು obey ಆಗುತ್ತೆ. Now, gas does not dissociate. When the gas does not dissociate, that time the law will be obeyed. Then the pressure is not too high. So pressure ಜಾಸ್ತಿ ಇದ್ರೂ obey ಆಗಲ್ಲ. So in a solvent, gas is not highly soluble. In solvent, gas is not highly soluble. Means example, ಈಗ solvent ಏನಾದ್ರು ಅಂತ ತಗೊಂಡಿದ್ದೀರಾ, gas we have taken it as a solute. Okay, solute ಆಗಿ gas ಅನ್ನು ತಗೊಂಡಿದ್ದೀರಾ, means solvent ನಲ್ಲಿ completely dissolve ಆಗಲ್ಲ. Yes, we know it already, right? So ಹೆಂಗ ಆಗುತ್ತಪ್ಪ gas completely dissolve, right? Next, temperature is not too low. Temperature ಬಹಳ ಕಡಿಮೆ ಇರಬಾರದು. ಮತ್ತೆ last one point, gas should be inert. Gas should be inert. Like example, NH3 ammonium is getting reacted with H2O to form NH4OH. Means what? It is a reversible process. Okay. So the volume of the dissolved gas does not depend upon pressure at a particular temperature. The volume of the dissolved gas does not, means volume of that dissolved gas. Okay, dissolved gas, a volume ಏನಿದೆ ಅಲ್ಲ dissolved gas ಇದ್ದು, that does not depend on the pressure at a particular temperature. It will not depend upon the pressure at a particular temperature. At particular temperature, it does not depend only. Okay, it does not depend only. Done. Next comes the application of Henry's law. So this is also important, guys. Okay. Next comes the application of Henry's law. In application of Henry's law, soft drinks bottles are sealed at high pressures to increase the solubility of CO2 in water. So soft drinks bottles are actually sealed at a high pressure to increase the solubility of CO2 in the water. If CO2 is completely dissolved into the water, okay, that time they will create the pressure inside it. Okay, if you create a pressure, it might happen like CO2 will be completely dissolved into the water. So whenever you open, the hiss sound will come, right? Hiss sound will come. So that thing will come when you create a pressure. Okay, so ಈಗ ಒಂದು example, simple example ಕೊಡ್ತೀನಿ. Soft drinks ತಗೊಂಡ್ ಬನ್ನಿ ಮನೆಯಿಂದ, okay, sorry, ಹೊರಗಿಂದ ತಗೊಂಡ್ ಬನ್ನಿ. When it is cold, that time you people bring it. Okay, when it's very much cold, you people bring it. So cold ತಗೊಂಡ್ ಬನ್ನಿ, ಸ್ವಲ್ಪ ಮನೆಯಲ್ಲಿ ಇಟ್ಬಿಡಿ. Okay, ಹೊರಗಡೆ ಇಟ್ಬಿಡಿ. So ಹೊರಗಡೆ ಇಟ್ಟು ಆಮೇಲೆ ಕ್ಯಾಪ್ ಇನ ತೆಗಿಬೇಡ್ರಿ. Okay, ಕ್ಯಾಪ್ ಒಟ್ಟು ತೆಗಿಬೇಡ್ರಿ. ಆಮೇಲೆ ಹಾಗೆ ತೆಗೆದ್ಬಿಡಿ ಕ್ಯಾಪ್. The hiss sound will not come. His sound will not come. Means ಏನು cool down ಆಗಿದೆ completely. It has been cooled down. There is no pressure inside, guys. There is no pressure inside. Now same bottle, you shake it very well and then afterwards you open. There the pressure has been created. And if in case, as I told you, pressure to increase the solubility of the CO2 is there, right? Now pressure has been created to increase it. Now pressure be created to dissolve the CO2. Now whenever the CO2 is getting dissolved inside the water, that time what happens? That time the sound comes. ಅದಕ್ಕೆ ಸುತ್ತ ಹೊರಗೆ ಬರುತ್ತೆ. ಯಾವಾಗ ಹೊರಗೆ ಬರುತ್ತೆ ಅನ್ನೋದು ಈಗ ತಿಳಿತಾ? ಏನ್ ಮ್ಯಾಮ್ ಹಾಗೆ ಹೆಂಗೆ ಏನೋ ಬರುತ್ತೆ ಬಿಡಿ ಅಂತ ತಿಳ್ಕೊಂಡ್ಬಿಟ್ರಾ? No, no, no. This is the reason why it's coming. Okay. Next comes the second point. Sea dives used a mixture of a O2 plus HE to minimize the painful effect by N2 in decomposition. Okay. Sea divers in ಮಾಡ್ತಾರಪ್ಪ dives andre they'll wear something no mask and all those things ಮತ್ತೆ ಹೋಗ್ತಾರಲ್ಲ ನೀರಿನಲ್ಲಿ ಏನೇನೋ ನೋಡ್ಲಿಕ್ಕೆ aquatic animals ಅನ್ನ so use it a mixture of O2 and helium ಮತ್ತೆ oxygen ದು mixture ತಗೊಂಡಿರ್ತಾರೆ to minimize the painful effect by N2 in the decomposition. So in the decomposition, the N2, if it is going inside our body, it is a poisonous to us. To decompose that, they are actually taking H2 and helium. Clear? Next, last point, at higher altitudes, breathing becomes tough as O2 is less available in the air due to the less pressure. Yes, higher altitude and the annual pressure, there will not be pressure anything created here. Like example, you think it now, you're going higher and higher, okay? You know, when the ಮೇಲ್ಗಡೆ ಹೋಗ್ತಿದ್ದೀರಾ ಅಲ್ಲಿ oxygen ಇರಲ್ಲ. ಯಾಕಪ್ಪ oxygen ಇರಲ್ಲ? Because there the content, the pressure will not be there to create the O2. So for that purpose, O2 will be very less there. Where the pressure is not there, O2 will not be there, means oxygen will not be there. For that purpose, if you go higher altitude, like example, I don't know now right now. So higher altitude nalli hodre adu oxygen baralla. Clear everyone? Done? Yes. Next comes the expression of concentration of solution solubility. Okay. Now what is the expression of concentration of a solution? And its solubility, first what we are going to learn it now. Clear? Understood? So let's start with the solubility. Now actually what happens in the solubility here? What happens in the solubility? One second guys. Yes. ಏನಂತಿದೆ solubility ನಲ್ಲಿ? So what they have told? Expression of concentration of solution. Concentration of solution guys. So the amount of the solute which is dissolved in the specific amount or a volume of the solution, it is denoted by C or yes. C or yes. So the amount of the solute which is being dissolved, okay, which is the amount of the solute which is dissolved in the specific amount of a volume. Specific agi a amount ಮತ್ತೆ volume of the solution ನಲ್ಲಿ ಆಗಿರುತ್ತೆ. ಅದು denote ಹೆಂಗ್ ಮಾಡ್ತಾರೆ? C or yes it is going to be denoted. Clear? Understanding? Yes. Now, how come the formula is gonna come? Formula in Bharatappa that C or S, that is weight of the solute in the gram, is divided by volume in the liquid, okay, or liter. Liter andre in the form of a liquid only it will be always, okay. Now weight of the solute in the grams. Weight of the solute means what? So how much weight of the solute you have taken it in the solid form only it should be. Why? Because they have mentioned it as a gram. Gram andre yavaglu neevu solid form nalline togolak beku, okay. It should be in the solid form itself. Clear? So this liter means it should be in the liquid form itself, okay. Now, what is going to be the formula? That is going to be the C is equal to N into E also can be written. Where N is going to be the normality of the solution and E is going to be the equivalent weight of the solute. E is going to be what? Equivalent weight of the solute. Done. Next, the concentration in the parts per million, that is ppm. So, when any amount of solute is present in 1 million, if it is present in the 1 million, that is 10 raised to 6 parts of the solution, then it is known as ppm. That is known as what? ppm, parts per million. Done? Parts per million. Clear? Yes. Next comes what? That is ppm is equal to mass of the A, that is mass of the A means any of the compound which they have given it, divided by total mass of the solution, total mass of the solution into 10 raised to 6, into 10 raised to 6. So this is also very important formula guys. The important formula, okay. Kantidana? Okay, done. Next comes what? Concentration of parts of a per billion. Okay, billion edu important ide. In form of KCET I am telling you. Boards nalli billion ashtu important illa. Okay, boards nalli ashtu important illa. Okay, but it is important in the KCET. Okay, important and they might ask. So when any amount of a solute is present in 1 billion, that is 10 raised to 9. So ಇಲ್ಲಿ ಎಷ್ಟಿತ್ತು ಇಲ್ಲಿ ಎಷ್ಟಿತ್ತು 10 raised to 6 ಇತ್ತು ಇಲ್ಲಿ ಎಷ್ಟಿದೆ 10 raised to 9 parts. Okay, just that is only the difference. Remaining things is going to be the same itself. Okay, so ಏನಾಗುತ್ತೆ PPB is equal to mass of the A divided by total mass of the solution into 10 raised to 9. Okay, so mass of the A ಎಷ್ಟಿದೆ ನೋಡಬೇಕು, ಆಮೇಲೆ total mass of the solution divide into 10 raised to 9. Then next comes molarity. So molarity is M. It is a number of the moles of a solute which is present in 1 liter of the solution. Which is present in 1 liter of the solution. Clear? So it is what? Number of the moles of a solute. ಎಷ್ಟಪ್ಪ moles ಇದೆ, ಎಷ್ಟಪ್ಪ moles ಇದೆ. ನೀವು ಹೇಗೆ ಫೈಂಡ್ ಮಾಡಬೇಕು moles? ಇದನ್ನ ಆಲ್ರೆಡಿ ನೀವು ಕಲ್ತಿದ್ದೀರಾ ನಿಮ್ಮ ಫಸ್ಟ್ ಇಯರ್ ಕ್ಲಾಸಸ್ ನಲ್ಲಿ, ರೈಟ್? ಸೊ ಫಸ್ಟ್ ಇಯರ್ ಕ್ಲಾಸಸ್ ನಲ್ಲಿ ಚಾಪ್ಟರ್ಸ್ ನಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಾ how to find the number of the moles. Clear? So it is the number of the moles of a solute. Molarity is also very important, guys. Okay, so it is a number of the moles of a solute which is present in 1 liter of a solution. ಎಷ್ಟಪ್ಪ moles ಇದೆ, moles ಇದೆ solute of the present. One second, guys. So ಎಷ್ಟಿದೆ, it is a number of the moles of a solute present in 1 liter of the solution and it is going to be denoted by M. Now whenever the molarity of the solution is 1, it is called as 1 molar solution. Yavaga mole is 1, then that time we are going to call it as what? 1 molar solution. Clear? We are going to call it as 1 molar solution. Now when M is equal to weight of the solute in the grams, how much is the weight of the solute in the grams? It means what? Molality. Molarity andre solid anta ನೆನಪಿಟ್ಕೊಂಬಿಡಿ, ಆಯ್ತದಾ? Solid and liquid. Solid divided by liquid. So M is equal to what? Weight of the solute in the grams. Means what? Grams or kg. Okay, once again I'll write it. So M is equal to, that is molarity, capital M, I'm written it here. So weight of the solute in the grams. Grams andre enu? Grams or kg, anything you can take it. Divided by molar mass into volume in liter. Okay, molar mass andre eshtu? Eshtappa molar mass ide, yavdu ತಗೊಂಡಿದ್ರಲ್ಲ solute ನೀವು ಅದರದ್ದು molar mass ಎಷ್ಟಿದೆ, that is going to be mm. Okay, mm into volume in liter. ಏನೇನು ವಾಲ್ಯೂಮ್ ತಗೊಂಡಿದ್ದಾರಲ್ಲ that should be in the form of a liter itself. It should be in the form of a liter itself. Clear? This is very important concept because ಇದ್ರ ಮೇಲೆ short question ಕೇಳ್ತಾರೆ. Short question ಕೇಳ್ತಾರೆ. Done? Am I correct? Next, in case of a dilution or mixing, M1 V1 is equal to M2 V2, that will be M3 V3. Okay, there M1 is equal to, how it is going to be reacting? M1 V1 plus M2 V2 divided by V1 V2. Means depends on that. Some questions ನಲ್ಲಿ ಏನು ಕೊಡ್ತಾರೆ, ಜಾಸ್ತಿ ವಾಲ್ಯೂಮ್ ಕೊಡ್ತಾರೆ, different types of ಈ chemicals ಗೆ ಇಷ್ಟು ವಾಲ್ಯೂಮ್ ತಗೊಂಡ್ವಪ್ಪ, ಈ preparation ಗೆ ಇಷ್ಟು ವಾಲ್ಯೂಮ್ ತಗೊಂಡ್ವಿ, ಆ ತರ ನೀವು depends on that we are going to write it. Okay, now A is going to be the acid there and B is going to be the base. Okay, and 1 there the solute is going to act, 2 where the solute is going to act, and both don't react with each other. They both don't react with each other. Next comes the molality. Now what is the meaning of molality? Number of moles of a solute dissolved in 1 kg of solvent. See, concentrate here. It is dissolved in 1 liter of a solution. Okay, 1 liter of the solution again molarity anta karitare. Illi molality, lity andre enu? Kg anta ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. Lity andre kg ಮತ್ತೆ molarity andre it's going to be the liter. Clear? So molality andre number of the moles of a solute which is dissolved in 1 kg of 1 kg of solvent. It is denoted by small m. It is going to be denoted as small m. Small m means what? Kg. Capital M means liter. Like that you can remember. Means you can write it down also as a note here. Has a note also at the side. You can write it down in your book. M, capital M means what? It is going to be the liter. And small m is going to be what? Kg. And this capital M is going to be what? Capital M ಏನಿರುತ್ತೆ? Molarity. And small m is going to be the molality. Clear? In this way, you can make a note and write it down. Okay, you can keep it. Means it will not be confusion that which is molality and which is molarity. Done? Now, next formula comes. Small m is equal to, that is molality is equal to weight of the solute in grams. How much is the weight of the solute in the form of a gram? Okay. And molar mass into weight of the solvent in the kg. Molar mass into weight of the solvent in the kg. Clear? So, m is equal to weight of the solute in grams. How much? Means yav solute ತಗೊಂಡಿದ್ದೇವಲ್ಲ in the form of a grams ನಲ್ಲಿ ಎಷ್ಟಿದೆ? Like 1 gram, 2 gram, 3 gram, depends on that. Okay. Then the molar mass into weight of the solvent in the kg. Solvent yav kg ತಗೊಂಡಿದ್ದೀರಾ? Like 1 kg ತಗೊಂಡ್ವಪ್ಪ, or else weight of how much? 249 weight. So ಅದರಲ್ಲಿ ಇದನ್ನ dissolve ಮಾಡ್ತಿದ್ದೇವೆ. 2 grams of something is we are getting dissolved in the solvent. ಆ ಥರ. Okay. Now, if a molarity of the solution is 1, it is called as molar solution. If the molarity of the solution is 1, it is called as molar solution. It's called as molar solution. Then, the concentration of 1 molar solution is less than that of the 1 molar solution. So, what is the concentration? Concentration of 1 molar solution. Okay. 1 molar solution though is actually less than that of the 1 molar solution. It's actually less than the 1 molar solution. Clear? 1 molar solution. Next comes molality is used preferably over molarity in experimental calculation, as molality is a temperature independent while the molarity is affected by the temperature. It is affected by the temperature. Clear? Done? Understood this? Yes. Next comes the normality and the formality. Normality and the formality. Clear? Normality. Now, it is a number of the gram equivalent of the solute present in the liter of a solution. So, it is what? Number of a gram of a equivalence. ಎಷ್ಟು gram of equivalence ಏನಿದೆ ಎಲ್ಲ solute ತಗೊಂಡಿದ್ದೇವಲ್ಲ ಅದರಲ್ಲಿ of that present in 1 liter of a solution. 1 liter solution ನಲ್ಲಿ weight of the solute in the grams you are going to substitute. Means in the solvent you are going to add 1 liter ನೀರಿನಲ್ಲಿ 1 gram of or 2 gram of solute you are going to add it. Okay. Next, and it is denoted by capital M, and capital M is equal to what? Weight of the solute in grams divided by equivalent mass. ಎಷ್ಟಪ್ಪ equivalent mass ಇದೆ? And into volume in liters. Volume in liters. If we solve the problems, you will get an idea about the formulas easily. Clear? So capital M, that is normality, is equal to weight of the solute in the form of a grams and divided by equivalent mass into volume in the liter. Volume in the liter. Done? Next, relationship between normality and molality. Relationship between the normality and the molality. Okay, understanding everyone? Yes? Clear? Yes. Next, relationship between the normality and molarity, that is N into equivalent weight is going to be what? Molarity into molar fraction. It's going to be what? Molarity and molar fraction, where N is equal to molarity into valency. Into valency. Valency andre ಏನು ಗೊತ್ತಿದೆ already outermost shell. Okay. Relationship between normality and molarity ಏನಿದೆ? Now N is into equivalent weight into is equal to molarity into molar mass. So ಎಷ್ಟು molarity ಇದೆಲ್ಲ ಅದರ into we are going to do the molar mass. So this is also important guys. ಇದನ್ನು ಮಾಡ್ಕೋಬೇಕು ಆಯ್ತಾ? Next. N is equal to molarity into number of the H plus ions or OH minus ions. Clear? So how it will be denoted? If in case they have given a hydrogen and oxygen, then we can denote it in this way. Clear? So this is all about the normality. Normality that is N is equal to weight of the solute in the form of grams divided by equivalent mass into volume in the liter. In volume in the form of a liter. This much you remember, more than enough. Clear, guys? Clear? Yes. Next, we are going to go for the formality. Formality andre enu? It is a number of the gram or formula present in a liter of a solution for an ionic solute. For an ionic solute. And it is denoted by F. It is denoted by what? F. Where F is equal to weight of the solute in grams. How much is the weight of the solute in the form of a grams divided by formula weight into volume in the liters. Formula weight and the volume in the liters. Formula weight ಎಷ್ಟಿದೆ ಅದು ಒಂದು ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಮೀನ್ಸ್ ಇನ್ ಕೇಸ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ C2H5 ಅದು ಫಾರ್ಮುಲಾ C2H5 ಇದು ಎಷ್ಟಪ್ಪ ಫಾರ್ಮುಲಾ ಯೂನಿಟ್ ಇದೆ ಅದು ವೇಟ್ ಇದೆ ಅದನ್ನ ನೀವು ಹಾಕಬೇಕು ಆಯ್ತಾ into volume in the liters. How much volume you have taken in the form of liters only you need to calculate. Okay, if in case they have given in the ml, then you need to convert that ml into the liter and then you need to write it here. Okay, ಅದಂತೂ ಶಾರ್ಟ್ ಮಾಡ್ಬೇಕು ನೀವು ಅದೇ ತರ. ಓಕೆ, now F is equal to what? Weight of the solute into divided by formula weight into volume in liter. Now it is applicable for the ionic solids like NaCl. So it's applicable for what? It's applicable most probably for the NaCl. Means what? For the salts it will be most probably affected a lot. Clear? Done? Next, so concentration terms, like very easy to remember. It means what? I have given in like a it's just like a flow chart. Okay, it's just like a flow chart to you people. It's just like a flow chart to you people. Flow chart andre enu ella ಒಂದರಲ್ಲಿನೇ ಅದೇ ಹೇಳಿದ್ ನಿಮಗೆ ಈ ತರ ಓದಿದ್ರೆ ನಿಮಗೆ ಈಜಿ ಆಗುತ್ತೆ ಅನ್ನೋದು ಆಯ್ತಾ. First becomes the what? Molarity, where molarity is the number of the moles of a solute per liter of a solution, where m is equal to moles of the solute divided by volume of the solution in the form of a liter. Then next comes what? Molality. Molality only m, where molality is the number of the moles of a solute per kilogram of the solvent, where m is equal to mole of the solute divided by weight of the solvent in kgs. Weight of the solvent in kgs. Done. Next comes the normality. Normality is what? Normality is the gram of the equivalent weight per liter. Equivalent weight per liter of the solution, where n is equal to gram equivalence of the solute divided by volume of the solution. Divided by volume of the solution in the form of a liter. Okay, next comes fourth one, formality, where formality is the number of the gram formula masses of the ionic solute which is dissolved in per liter of a solution, which is got dissolved in the per liter of the solution. Done. So m is equal to what? Weight in gram divided by formula weight into volume of the solution in liters. Volume of the solution in the form of a liters. Clear? Next comes the mole fraction, where mole fraction is the number of the moles of one component which is got divided by into total number of the moles of a whole components of a solution. Whole components of a solution. That is going to be what? Xz is equal to n1 divided by n2 plus n1. Okay, I know it might be not looking to you visible to you people properly, but in the form of a notes it will be visible clearly to you. Okay, parts per million just explain ಮಾಡಿದೆ. Means what? This is just a small chart, flow chart, which is actually helping you people. Means one page ನಲ್ಲಿನೇ ನಿಮಗೆ ಎಲ್ಲ concentration terms easy ಆಗಿ ಕಲಿಬಹುದು. Right, so like that only you also need to make it. Okay, you also need to make your own notes. So ಯಾವ ತರ notes ಅನ್ನ prepare ಮಾಡ್ತಾರಲ್ಲ ಆ ತರ ನಿಮಗೆ help ಆಗುತ್ತೆ. Okay, it will help you people according to that. Make sure you will do those things according to that also. Okay, clear? Done. Next comes the mole fraction, which you are going to learn it in detail about it. So before that, just a 2 minutes break I will be giving you. 2 minutes break, guys. I'll have a water and come. Okay, soon, quickly. Yes, let's start with the mole fraction. Okay, mole fraction of the component is given by the moles of one component and divided by the total number of moles of present in that of the solution, like it is expressed in the form of x itself. It is expressed in the form of x. ಇಲ್ಲಿ ಬರಿಲ್ಲ bracket ನಲ್ಲಿ. For example, for a binary solution, two components A and B, mole fraction of A, that is XA, is equal to NA, that is NA plus NB. In case mole fraction of B, that is XB, is equal to NB divided by NA plus NB. ತಗೊಳ್ಳಿ ಈಗ NA ಮತ್ತೆ NB ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿರ್ತಾರೆ. ಓಕೆ, ಯು ವಿಲ್ ಹ್ಯಾವ್ ಅ ಫಾರ್ಮುಲಾ ಆಫ್ NA and NB. ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ? ವಾಲ್ಯೂಮ್ ಏನೋ ಕೊಟ್ಟಿರ್ತಾರಪ್ಪ NA ಮತ್ತೆ NB ಇದು. ಅದರಲ್ಲಿ ಏನು ಆನ್ಸರ್ ಯಾವ್ದು ಜಾಸ್ತಿ ಇದೆ ಅಲ್ಲ, ಫಸ್ಟ್ ಅದನ್ನ NA ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ವಿ. ಫಸ್ಟ್ NA ಅನ್ನ ಫೈಂಡ್ ಮಾಡ್ಕೊಂಡ್ವಿ, ಆಮೇಲೆ NB ಅನ್ನ ಮೀನ್ಸ್ XA and SB. ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ XA and mole fraction of XB. Done? Clear? Yes. Next, Na is equal to number of the moles of A, that is solute. Number of moles of A, that is going to be the solute, and NB is equal to number of the moles of B, that will be the solvent. Okay, number of moles of B, that will be the solvent. Now weight of the percentage is going to be W, means W divided by W into 100. It is the weight of the solute present in 100 gram of a solution into the 100 gram of a solution. W divided by D, W divided by W into 100. 100 ಅಂತ ಇರಬೇಕು, because ನಾವು percentage find ಮಾಡ್ತಿದ್ದೇವೆ. percentage find ಮಾಡ್ರೆ 100 ಅಂತೂ short ಆಗಿ ಇರಲೇಬೇಕು. So that is going to be what? Solute, how much it's present in 100 gram of solution. 100 gram of solution ನಲ್ಲಿ ಎಷ್ಟಪ್ಪ solute present ಇದೆ, ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್. ಸೊ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್ V is divided by V, means ಇಲ್ಲಿ WW ಅಂದ್ರೆ in form of kg or a gram. This is in the form of a liter or a ml. It is in the form of a liter or a ml. Now it is a volume of the solute present in 100 ml of a solution. It is present in 100 ml of a solution. Clear? Done? Yes. Next, mole percentage is equal to moles of a solute divided by total moles of a present in the solution into 100. So how you can calculate the mole percentage? Mole percentage can also be calculated in the form of moles of a solute. How much is the moles of a solute? Means solute the moles ಎಷ್ಟಿದೆ that will be divided by total moles of a present inside the solution. Solution ಅಂದ್ರೆ ಏನಪ್ಪ? Solution means again it will come what? Solution ಅಂದ್ರೆ ಏನ್ ಮತ್ತೆ ಬರುತ್ತೆ? Solute plus solvent ಬರುತ್ತೆ, right? So ಅವೆರಡರದ್ದು ಫೈಂಡ್ ಮಾಡಿ ಆಮೇಲೆ ಅದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು ಆಯ್ತಾ. So this is also very important formula guys. Done? Next, mass fraction. The ratio of the mass of the component to the total mass of the solution is known as mass fraction, where it is given for the solution which contains WAG of A and WBG of a B. WBG of a B and WAG of a. Clear? Now where mass fraction means mass of the fraction A, XA, that is going to be how much? That will be how much? WA divided by WA into WB. So mass fraction of A component do other XA ಏನಿದೆ ಅಲ್ಲ, how it can be done? It can be denoted as WA divided by WA plus WB. WA plus WB. Done? Next comes the mass fraction of B. Mass fraction of B, how you will calculate? That is XB is equal to WB divided by WA plus WB. Clear? Mass fraction. Okay, ಈಗ ಏನು mole fraction ಕಲ್ತ್ವಲ್ಲ, mole fraction ನಲ್ಲಿ actually ಏನು ಕಲ್ತ್ವಿ ನಾವು? In the form of what we have learned it about the moles we have learned it. Okay, mole fraction ನಲ್ಲಿ moles ಕಲ್ತಿದ್ದೇವೆ. So for that purpose we were using everywhere the N. Clear? NA divided by plus NB, NB divided by NA plus NB ಅದನ್ನ ಕಲ್ತ್ವಿ. ಸೇಮ್ ಅದೇ ತರ ಇಲ್ಲಿ ಮಾಸ್ ಅದು. ಮಾಸ್ ಅಂದ್ರೆ ಏನು? we will consider mass as a W. Okay, consider denote ಏನು ಮಾಡ್ತೀವಿ? mass ಗೆ W ಅಂತ denote ಮಾಡ್ತಿದ್ದೇವೆ. Okay, so we are writing as WB divided by WA plus WB. Done? This both are also very important. So the XA is equal to XB is equal to 1. Clear? Theta. So XA plus XB is equal to 1. Clear? Next, when 1 mole of a solute is present in 1 liter of a solution, okay? Yavaga 1 mole of a solute is present. Yavag 1 mole of a solute, edrallirutte 1 liter of a solution alliruttalla, avaga at 0 degrees Celsius, that will be tolerated as 1 demol solution. ಏನು ಕರೀತಾರೆ ಅದಕ್ಕೆ 1 demol solution ಅಂತ ಕರೀತಾರೆ. 1 demol solution ಅಂದ್ರೆ ಏನು? 1 demol solution ಅಂದ್ರೆ ಏನಪ್ಪ? So ಯಾವಾಗ 1 mole, okay, 1 mole solute ಎದ್ರಲ್ಲಿರುತ್ತೆ? It is present in 1 liter of 1 liter of solution at how much temperature? At 0 degrees Celsius. At 0 degrees Celsius. That is going to be what? Demol solution. Clear? So always remember 1 molar is always greater than the 1 molal. Okay? It's always greater than the 1 molal. Clear? Understood? Yes. Let's move to the next, that is relationship between the molarity M and molality M. So let molarity M and molality is going to be the small m. Done. We know this thing. Right? We know what is a molarity and what is a molality. It is denoted how the denoted has been done. Next comes mass of a solute W in the form of a grams and mass of a solvent in the form of a grams is going to be the W. Now M2 is equal to molar mass of a solute. M2 is equal to what? Molar mass of a solute, and D is equal to density of a solution. So M2 ಅಂದ್ರೆ ಏನು? Molar mass of a solute ಅಂತ consider ಮಾಡ್ಕೋಣ, and the mass of the solvent in the grams is W, and M2 is going to be the molar mass. Okay, M2 is going to be the molar mass of a solute, and D is going to be the density of the solution. So the mass of the solvent is going to be 1000 D minus M2 gram. Clear? So as of that, the relation how it will be, M is equal to W divided by M2 into 1000 divided by W. 1000 divided by W. So for that purpose, small m is equal to capital M divided by 1000 D minus M2. 1000 D minus M2 into 1000. Clear? So ಇದನ್ನ ಮತ್ತೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ m is equal to capital M divided by in 1000 ಈ ಕಡೆ ತಗೊಂಡ್ವಪ್ಪ. Okay, D minus M2 divided by 1000. Clear? Done? Okay, understanding? Yes. Next concept comes the vapor pressure. So what is the meaning of a vapor pressure? Vapor pressure is going to be when the vapor phase is in equilibrium with the liquid, it is for the given temperature, then the pressure is being forced. Okay, pressure has been forced. Whenever the vapor phase is in the equilibrium with the liquid, it is actually liquid in the form of a given temperature, then the pressure forced by the vapors is known as what? Vapor pressure of the liquid. Okay, vapor pressure of the liquid. Now what is the meaning of a vapor pressure of the liquid? In a short form I will tell you, people. Okay, in a short form I will tell you. Wait one second, I'm a pencil. Okay, so vapor pressure, how it's been formed in the liquid ಹೇಳ್ತಾನೆ. ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ವೆಸಲ್ ತಗೊಂಡಿದ್ದಾರೆ. Okay, now we have taken one vessel. ಆ ವೆಸಲ್ ನಲ್ಲಿ we have added a water to it. Okay, we have added a water to it and we have closed the container. Okay, we have closed that container. Once you take that vessel and you have closed that container, inside that vessel there is a water. You have applied the temperature now. Okay, a temperature na full apply ಮಾಡಿದ್ದಾರೆ. Temperature ಯಾವಾಗ apply ಮಾಡ್ತಾರಲ್ಲ, ಆ ನೀರ್ ಏನ್ ಇರುತ್ತಲ್ಲ, inside what is the temperature present is there, it will start boiling. Okay, it will start boiling. Now there is no place for the gas to go out. Okay, gas ಗೆ ಹೊರಗಡೆ ಹೋಗ್ಲಿಕ್ಕೆ ಏನು ಜಾಗ ಇಲ್ಲ. ಎದಕ್ಕೆ ಜಾಗ ಇಲ್ಲ? Why? Because there is not having, means this is a closed container. ರೈಟ್. ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ನಲ್ಲಿ ಗ್ಯಾಸ್ ಹೋಗ್ಲಿಕ್ಕೆ ಎಲ್ಲೂ ಜಾಗ ಇಲ್ಲ ಅಂದಮೇಲೆ ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Clear? That pressure which is being getting created there, that pressure is only again ಮತ್ತೆ pressure ಮತ್ತೆ liquid form ನಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಗ್ಯಾಸ್, ಮತ್ತೆ ವೇಪರ್ಸ್ ಫಾರ್ಮ್ ನಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಆ ವೇಪರ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಿದೆ ಅಲ್ಲ, that will vapor pressure will get converted into the liquid again. ಕ್ಲಿಯರ್? ನೀವು ನೋಡ್ಬೋದು, ಯಾವ್ದಾದ್ರು ಒಂದು ವೆಸಲ್ ತಗೊಳ್ಳಿ, ಅದನ್ನ ಕ್ಲೋಸ್ ಮಾಡಿ ನೀರನ್ನ ಬಿಸಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಓಕೆ, ಸ್ವಲ್ಪ ಹೊತ್ತಾದ್ಮೇಲೆ ನೋಡ್ಬೇಕು ಪ್ಲೇಟ್ ಆಕ್ಚುಲಿ ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರೆಷರ್ ಪ್ಲೇಟ್ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್, ಮೂವ್ ಆಗ್ತಿರ್ತದೆ. ಓಕೆ, ಸೊ ಯಾವಾಗ ಮೂವ್ ಆಗ್ತಿರುತ್ತಲ್ಲ ಅವಾಗಂತೂ ಏನು ಮಾಡಬೇಡಿ, ಲೆಟ್ ಇಟ್ ಗೆಟ್ ಬಾಯ್ಲ್ಡ್. ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ಜಸ್ಟ್ ಕ್ಲೋಸ್ ಇಟ್. After sometimes you just off the gas, and then afterwards you open the lid of it. At the back side of the lid, full of water molecules will be there, vapor molecules will be there. Those vapor molecules is being created because of the vapor pressure. It's got created with the help of vapor pressure. That is what you need to understand it here. Done? So what is that? That is nature of the liquid and the temperature are the two dependent properties for it. Or it is actually a two dependent properties of it. And vapor pressure of a solution is always lesser than the vapor pressure from its pure liquid state. Okay, yavaga vapor pressure of the solution is always lesser than the vapor pressure of a pure liquid. Clear? Next, for having an idea of an attractive force between the molecules of a liquid, vapor of a liquid is used. Force of attraction has inverse relationship with vapor pressure. It's actually an inverse relationship with the vapor pressure. Example in ತಗೋಬಹುದು, P0 C6H5 or C2H5 is actually greater than the P0 of C2H5OH, and it's being greater than the H2O, and it's being greater than the glycol. This is the simple example which we can take it. Done? Next, with the increase in the temperature, pressure of the liquid also will increase. So pressure of the liquid also will increase. Obviously, if in case we are increasing the temperature of that vapor, then the pressure also will start increasing to create a bubbles there, to create a vapor molecules there, right? So that has a kinetic energy of a molecules also will increase. For that purpose, the kinetic energy also will start increasing. If in case increase of temperature is happening, then the vapor pressure of the liquid also will increase. Vapor will also increase. Done? So for that purpose, kinetic energy also will increase. Clear? This you remember. Done? Now, the variation of a vapor's pressure with temperature can be given by calculus Capron equation as follows. Log 10 P2 divided by P1 is equal to delta H vap divided by 2.303 R in the bracket T2 minus T1 divided by T1 T2. Okay, T1 T2. Done? So this also you should remember. Formula. Clear? This is also important, guys. You should remember this formula also. Done? Understanding? Yes? Understanding? Ivunella nenapitkobeku. Clear? So if you remember this much, it will be easy for you to understand about the vapor pressure. Okay? It will be easy to understand about the vapor pressure. So next comes vapor pressure of a solution. So what is the meaning of a vapor pressure of a solution? One second, guys. So vapor pressure of a liquid is done now. So now next comes the vapor pressure of a solution. So whenever the pure solvent is added to a miscible solute, then they form a solution. There is a decrease in escaping the tendency of the solvent molecules, as some molecules of the solute will replace actually. Okay, some of the molecules will start replacing. Sorry, where it went? One second, guys. Yes. Whenever this pure solvent is added in a miscible solute, then they form a solution. There is a decrease in escaping the tendency of the solvent molecules. As some of the molecules of a solute will replace the molecules of a solvent from the surface, this causes the decreases in the vapor pressure. Yes, same way. Now we have taken one container, you have added a water to it. When you add a water to it, what will happen actually there? What is an important concept what we are going to do here is, ಆ ಕಾನ್ಸೆಪ್ಟ್ ನಲ್ಲಿ ನೀರ ಬಾಯ್ಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇಡ್ತೀರಾ. ಓಕೆ, ಟೆಂಪರೇಚರ್ ಒಂದು ಅಪ್ಲೈ ಮಾಡಿ ನೀರು ಬಾಯ್ಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇಡ್ತೀರಾ. ಓಕೆ, ನಾವು ವೆನ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಅಪ್ಲೈಯಿಂಗ್ ಅ ಟೆಂಪರೇಚರ್ ಅಂಡ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್, ಯು ಹ್ಯಾವ್ ಆಡೆಡ್ ಒನ್ ಸಾಲಿಡ್ ಕಂಪೋನೆಂಟ್ ದೇರ್ ಟು ಗೆಟ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ಸೈಡ್ ಇಟ್. ಓಕೆ, ಮತ್ತೆ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ಇದೆ, ಇಟ್ಸ್ ಅ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್. ಸೊ ದಟ್ ಟೈಮ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಅಂಡ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಅಂಡ್ ದ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಅಗೇನ್, ಮೀನ್ಸ್ ಸೈಕಲ್, ಇದು ಸೈಕಲ್ ಪ್ರೊಸೆಸ್. ಇದು ಈಗ ನೀರು ಹೋಗುತ್ತೆ, ವೇಪರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ, ವೇಪರ್ molecules and the matte neerige barutte. Means what? The surface tension, it will not allow the solute to dissolve in it properly. Now it is going to dissolve how? It depends on how much temperature you are going to apply that. Clear? So now next, the vapor pressure of a pure solvent is more than that of its solution, and if the vapor pressure of the solvent is P0 and that is of the solution is Ps, then the lowering of the vapor pressure P0 minus Ps. Clear? So when there is a decrease in the surface area occupied by the solvent molecules and an increase in the density, the vapor pressure of a solution will also start decreasing. What happens with the vapor pressure of a solution? It will start decreasing. Clear? Next comes the Raoult's law. Clear? So in Raoult's law for the volatile solute, and we have in the Raoult's law for the non-volatile solutes also. So we have both the things, one with the volatile solute and one more with the non-volatile solutes. Clear? Okay, then let's start with the first with the Raoult's law for the volatile solutes. Okay, first volatile solutes na nodkona, ಆಮೇಲೆ non-volatile solutes na nodona. So first comes what? Volatile liquids or volatile solutes. So adರಲ್ಲಿ it states that for a given solution, the vapor pressure of the component for a given temperature is actually equal to what? Is equal to multiplication of the mole fraction of that component in the solution. Clear? So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಏನು ಸ್ಟೇಟ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, ಏನು ಗಿವನ್ ಸೊಲ್ಯೂಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಆ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಸೊಲ್ಯೂಟ್ ಮತ್ತೆ ಸಾಲ್ವೆಂಟ್ ಎರಡು ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ನಾವ್ ದ ವೇಪರ್ ವಿಚ್ ಇಸ್ there, the vapor pressure of that component, of any component there, that vapor pressure, what is there? That is actually equal to the multiplication of the mole fraction. It's actually multiplication of the mole fraction of the component in the solution, of the component in the solution. Done. And the Vp of that component, that is vapor pressure of that component, I'll write it down, don't get confused. Okay, vapor pressure of that component in its pure state for the same temperature for a solution containing two components A and B, and the total vapor pressure of the pressure P, or how much it will be for the P. Okay, so ಏನಾಗುತ್ತೆ, PA is actually equal to P0 A into XA. XA ಅಂದ್ರೆ ಏನು? Mole fraction. Clear? One second, guys. Yes. ಆಯ್ತಾ? ಸೊ ಪಿ ಬಿ ಮತ್ತೆ ಸೇಮ್ ಯಾವ ಕಾಂಪೋನೆಂಟ್ ಮಾಡ್ತಿದ್ದೀವಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ನಾವು ತಗೋಬೇಕು. ಪಿ ಎ ಒಂದು ಬರುತ್ತೆ ಮತ್ತೆ ಪಿ ಬಿ ಒಂದು ಬರುತ್ತೆ. ಸೊ ಪಿ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ನಾಟ್ ಬಿ ಇಂಟು ಎಕ್ಸ್ ಬಿ, ಪಿ ನಾಟ್ ಬಿ ಇಂಟು ಎಕ್ಸ್ ಬಿ. ಎಕ್ಸ್ ಬಿ ಅಂದರೆ ಇದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, ಸೊ ಫಾರ್ ದ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಎ, yes, PA plus PB, that is PA plus PB, this both the things are going to get added up here. So we are going to get this equation. Clear? We are going to get this equation. Done? Yes, let's understand the non-volatile solution also. Before that, you have to have an idea like mole fraction ನಲ್ಲಿ ಯಾವ್ಯಾವ ತರ ಕಂಪೋನೆಂಟ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಅನ್ನೋದು. ಓಕೆ, ಇಲ್ಲಂತೂ ಎಕ್ಸ್ ಎ ಮತ್ತೆ ಎಕ್ಸ್ ಬಿ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ದೇ ಹಿಯರ್ ವಿ ಆರ್ ಟೆಲ್ಲಿಂಗ್ ಅಬೌಟ್ ದ ಎಕ್ಸ್ ಎ ಅಂಡ್ ಎಕ್ಸ್ ಬಿ. ಒನ್ ಸೆಕೆಂಡ್ ಗೈಸ್. ಎಸ್, ಇಲ್ಲಂತೂ ಎಕ್ಸ್ ಎ ಮತ್ತೆ ಎಕ್ಸ್ ಬಿ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, ರೈಟ್? So now here XA plus XB is equal to 1, where XA is going to be considered as 1 minus XB, and that P is equal to 1 minus XB P naught A plus P naught B XB. So P is equal to what? P naught B minus P naught A XB plus P naught A. Clear? So ಏನಾಗುತ್ತೆ, ಫಸ್ಟ್ ನಾವು XA ವ್ಯಾಲ್ಯೂ ಹಾಕಿರ್ತೀವಿ. ಓಕೆ, ನಾವು XA ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಮಾಡಿದ ತಕ್ಷಣ ಆ XA ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಇದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೇವೆ. ಓಕೆ, we have just substituted it here. Like example, P is equal to what we know already now. So we know already that P is equal to P naught A and XA. Okay, then plus P naught B XB. Done. P naught A XA plus P naught B XB. Clear? Understanding? Understanding? Yes. Now next comes what? In this only we are going to substitute the value of XA. Okay. P is equal to P naught A. XA value in ಕೊಟ್ಟಿದ್ದಾರೆ 1 minus XB plus remaining things just let it be same itself. Okay. Remaining things let it be same itself. Clear? Done? Understanding? ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಈಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರಪ್ಪ ಸೇಮ್ ಅದೇ ತರ, ಆಮೇಲೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು. ಇದೇನ್ ಸೇಮ್ ಇದೆ ಅಲ್ಲ, ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು. P naught A into 1 is how much? ಆಮೇಲೆ P naught A into XB is how much? Understanding? We are just multiplying the things. Okay, we are just multiplying the things. Plus P naught B, sorry, P naught A ಉಳಿಯುತ್ತಾ? One second guys. Yes, so we did mistake here. So ಇಲ್ಲಿ P is equal to P naught A 1 minus XB ಅಂತ ಹಾಕಿದ್ವಿ. Done. Now next step is what we're going to do is we need to multiply P naught A into 1 and P naught A into XB. Done. Let us do it step by step, then only we are going to get it. Okay, minus, done, plus. Now in this both there is a common thing present, right? So P is equal to, what is common in this both the things? What is common in this both the things? I'm rotating like that only na. So idri ಎರಡರಲ್ಲಿ ಕಾಮನ್ ಏನಿದೆ, XB ಕಾಮನ್ ಇದೆ, XB ಕಾಮನ್ ಹಾಕಿದ್ವಿ. And again what is common here? P naught A. Okay, P naught A ಇದೆ, ಆಮೇಲೆ minus P naught A ಬರುತ್ತಾ? One second, let us write it as, ತಿಳಿತಿದೆ ಅಲ್ಲ ಎಲ್ಲರಿಗೂ? So ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿ? P naught B minus P naught A, done, plus P naught A. Done? Done? Yes. This is what we have got the answer also here. Okay, how we got the answer, that is the main. Next, has P naught A and P naught B as a constant at the particular temperature. Hence, the PT is the linear function of the mole fraction. That is going to be the XB. Now, what is the meaning of a Raoult's law of a non-volatile? So, volatile nalli enagutte? Volatile nalli we are going to get a product in this way. Clear? So, in volatile there will be a equal, means equal to the multiplication of the mole fraction of that component. But in non-volatile what happens? Raoult's law states that the relative lowering of vapor pressure of a solution containing a non-volatile solute is actually equal to the mole fraction, of a solute in the solution. Mole fraction of a solute means what? Which is in a lesser quantity. In solute ಇದೆಲ್ಲ ಅದರದ್ದು mole fraction ಏನಂತ ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ. ಎತ್ತರದು ಯಾವ ಸೊಲ್ಯೂಷನ್ ನೋಡ್ತಿದ್ದೇವಲ್ಲ ಆ ಸೊಲ್ಯೂಷನ್ ಪ್ರಕಾರನೇ ಇದಾಗೋದು, ಆಯ್ತಾ? ಸೊ ಯಾವ ಸೊಲ್ಯೂಷನ್ ನೋಡ್ತಿದ್ದೇವೆ, ಇನ್ ಕೇಸ್ ಯಾವುದೋ ಒಂದು ಸೊಲ್ಯೂಷನ್ ರೈಟ್ ನಾವು ನೋಡ್ತಿದ್ದೇವೆ, ಸೊ ಆ ಸೊಲ್ಯೂಷನ್ ಪ್ರಕಾರಲಿ ಅದರಲ್ಲಿ ಏನು ಸೊಲ್ಯೂಟ್ ಇದೆ ಅಲ್ಲ ಅದರದ್ದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ನಮಗೆ ಗೊತ್ತಿರಬೇಕು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ, ಆಯ್ತಾ? ಲೆಟ್ ಅಸ್ ಚೆಕ್ ಇಟ್ ಔಟ್ ಹೌ ಇಟ್ ವಿಲ್ ಕಮ್ ನೌ. ಸೊ P naught minus PV divided by P naught. is equal to N2 divided by N1 plus N2. This is about the mole fraction is equal to X2. Now X2 is going to be the mole fraction of a solute, that is X2, and N1 is going to moles of a solvent. Always remember, N1 will be in a more amount and N2 will be in a lesser amount. Why? Because solvent will be in a more amount and solute will be in a lesser amount. Done. Then afterwards P2 is equal to vapor pressure. Pk is equal to vapor pressure of the solution and P0 is equal to vapor pressure of the pure solvent. Done. This much everyone clear? Yes. Let's start with the next now. Ideal solution. So in Raoult's law, both the things are important. In Raoult's law, both the things means in this non-volatile is also important and even the volatile is also equal. Okay. So this much you people need to remember. I have just highlighted it. While you will be seeing the notes, it will be easy for you to understand it. Okay, easy agutte understand madlikke. Done. Next, ideal solution and non-ideal solution is also very important, guys. So ideal matte non-ideal solution melenu bala important types of questions also will be asked on them. Clear? So now ideal solutions are the solutions in which solute and solvent interactions are almost similar to the solute interactions. So yavaga ideal solution alli solute interaction matte solvent interaction iruttalla, almost it will be same exactly, not I can say, but almost it is similar. Like example 98%, 95% similar irutte solute matte solvent interaction shode. Clear? So that is what they are trying to tell for the ideal solution. So in a simple way, what they will mention, AA and BB are almost equal. Means what? Solute and solvent interaction is almost equal to the solute interaction and a solvent interaction. Done. So now, and such solutions satisfy the following requirements. So it satisfies the following requirements. Means what? Ideal solution nalli this ideal solution appa anta nimage heng gottagutte avu satisfy ಮಾಡಬೇಕಲ್ಲ. ಈಗ ನಿಮಗೆ ಯಾರಾದರೂ ಒಬ್ರು ಈಗ ಮುಗಿತಪ್ಪ ನಿಮ್ಮ PUC. ಓಕೆ, ಸೊ ನೀವು ಇಂಜಿನಿಯರಿಂಗ್ ಹೋದ್ರಿ, ಈಗ ಇಲ್ಲಾಂದ್ರೆ ಇನ್ ಕೇಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಹೋದ್ರಪ್ಪ, ಸ್ವಲ್ಪ ಮಂದಿ ಡಾಕ್ಟರ್ಗೆ ಹೋಗ್ತಾರೆ, ಎಲ್ಲೂ ಹೋದ್ರಿ ನೀವು, ಡಿಗ್ರಿ ಮುಗಿದ ತಕ್ಷಣ ನಿಮ್ಮದು ಇಂಟರ್ವ್ಯೂಸ್ ಇರುತ್ತೆ. ಇಂಟರ್ವ್ಯೂ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರಲ್ಲ ನಿಮ್ಮ ಕಾಲೇಜಸ್ನಲ್ಲಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸ್ಪೆಷಲಿ ಮೇನ್ ದೇ ವಿಲ್ ಸಿ ದ್ಯಾಟ್ ವಾಟ್ ಟೈಪ್ ಆಫ್ ಅ ಪ್ರಾಜೆಕ್ಟ್ ಯು ಹ್ಯಾವ್ ಡನ್. ಓಕೆ, ಯಾವ ಥರ ಪ್ರಾಜೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ ನೀವು, ಮತ್ತು ಯಾವ ಥರ ನಿಮ್ಮ ಸ್ಕಿಲ್ಸ್ ಇದೆ, ನೀವು ಏನೇನು ಕಲ್ತಿದ್ದೀರಾ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಇಂಜಿನಿಯರಿಂಗ್ನಲ್ಲಿ C+ ಕಲ್ತಿದ್ದೀರಾ, ನಾವು ಪೈಥಾನ್ ಬರ್ತಿದೆ ಏನೇನೋ. ಸೊ ಇವೆಲ್ಲ ಗೊತ್ತಿರ್ಬೇಕು ನಿಮಗೆ ನಾಲೆಜ್, ರೈಟ್? ಸೊ ದ್ಯಾಟ್ ಇಸ್ ವಾಟ್ ದೇ ಆರ್ ಸರ್ಚಿಂಗ್ ಸಮ್ ಸೆಟ್ ಆಫ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ದೇರ್. ಓಕೆ, ಒಂದು 5 ರೂಲ್ಸ್, ಈ 5 ಥಿಂಗ್ಸ್ ಅಪ್ಪ ಈ ಹುಡುಗನಲ್ಲಿ ಇದ್ದರೆ ಐ ವಿಲ್ ಟೇಕ್ ಹಿಮ್. ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ದೇರ್ ಇನ್ ದ ರಿಕ್ರೂಟರ್ ಮೈಂಡ್. ಓಕೆ, ರಿಕ್ರೂಟರ್ ಮೈಂಡ್ನಲ್ಲಿ ಏನಿರುತ್ತೆ, ಸೊ ಇವನ ಕಡೆ ಇದು ಬರ್ತಿದೆ, ಇವಳ ಕಡೆ ಇದು ಬರ್ತಿದೆ, ಓಕೆ ನಂಗೆ ಇದು ಬೇಕಿತ್ತು, ಅವಳ ಕಡೆ ಅದೇ ಇದೆ, so she will get selected or he will get selected. How this is happening? This is because they have planned it. According to that only, here also to become an ideal solution, we have some rules. Okay, ಸ್ವಲ್ಪ rules ಇರುತ್ತೆ, ಅವು accept ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಮುಗಿತು. That is called as ideal solution. Clear? So they obey the Raoult's law for all the ranges of the concentration and temperature. So whatever the range is, whatever the concentration is, doesn't matter to them. They will obey the Raoult's law. Clear? And we know already what is the meaning of Raoult's law. Clear? Next, delta H is equal to 0 always. Delta V is also always is equal to 0. And vapor pressure of OB is equal to vapor pressure of XP. And BP is equal to VP. And no dissociation or association takes place here. So there will be no dissociation and association is possible here. Next comes the definition. So in a simple way, this is what actually you need to remember. But in a KCET perspective, this all things are very important because they might twist the answers, twist the questions, and they might ask in the application based questions. Okay, application based questions nalli inta type of questions keltare aita. So adar salaga helodu NCERT line to line odidre KCET bhಳ help ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ನಾವು ತಗೊಂಡಿರೋದಲ್ಲ. Right? So definition, an ideal solution is that solution in which each component will obey the Raoult's law under all the conditions of temperature and concentration. Ideal solution will obey the Raoult's law. This much also if you write, if you remember, it's more than enough. Because KCET nalli ನೀವೇನು ಹೋಗಿ theory ಬರೀತಿಲ್ಲ, right? You're not writing the theory there, right? But You should be knowing the concept very well to answer those questions of the KCET, right? So this is what you people can do it. Done. So this is also very important, guys. Done. Next. No chemical reaction between the solute and the solvent is possible. So there will be a no chemical reaction between the solute and the solvent, and it does not form azeotrope mixture. So in form agala azeotrope mixture form agala. Clear? Examples okay? So that is benzene plus toluene is the best example for that. Okay, benzene with the toluene, nice reaction will be happening. Means what? They both will obey the Raoult's law. They at whatever the temperatures. It's just think like benzene is having a high temperature right now and toluene is having a less temperature. Doesn't matter to them. It's obeying the Raoult's law. It's more than enough. Then it is called as an ideal solution. Simple, right? Same like that only hexane and heptane, ethyl bromide and ethyl iodine, chlorobenzene and bromobenzene, CCl4 plus SiCl4, all the dilute solutions. So most of the dilute solutions will act like an ideal solution. Why? Because they are already diluted, the concentration will be already be less. It's not like with the concentration is more and there the exothermic endothermic processes are happening in that concentrations. So then it will be a problem little bit to obey the Raoult's law, right? Even though it's a no condition of the temperature and pressure, but also sometimes it doesn't obey. For that purpose only, almost all dilute solutions will be accepted as ideal solutions. Clear? So this is how the graph is gonna come according to its pressure. Okay, like vapor pressure according vapor pressure versus mole fraction. So vapor pressure versus mole fraction here XA is actually equal to 1 and XB is actually equal to 0. So here what happens, the thing is, one second guys. Yes, so whatever the happening here thing is, it's actually like according to the temperature and pressure it's happening. Okay, just concentrate properly now. Here the mole fractions are there, XA and XB. Clear? Done. So now whenever the mole fraction is been increasing, okay, it's increasing till P naught B. Done. It's increasing till P naught B. Next comes what? It's actually according to this mole fraction, according to this thing, that's actually again it's increasing, right? So for that purpose, this is the total pressure what is going to get. Clear? According to the XA and XB of mole fractions of both the sides, we are going to get the total pressure has P1 is equal to PA plus PB. That's what we found it in the Raoult's law also, right? So that is what we learned it in the Raoult's law. Clear? Next, non-ideal solutions. So what happens in the non-ideal solutions? So now ideal solutions, you got to know what is ideal solutions. Ideal solutions are those who will actually obey the Raoult's law. Done. Now what is non-ideal solution? Let's see. In non-ideal solution are the solutions in which solute-solvent interaction is different. Okay, allenagittu solute-solvent interaction is actually same to the solute-solute interaction and solvent-solvent interaction. But here what is happening? Non-ideal solutions are the solutions in which solute-solvent interactions are different from solute-solute and solvent-solvent interactions. These solutions do not obey the Raoult's law for the concentration, and even here the delta H and delta V is also not equal to 0. Clear? Delta H and delta V is also not equal to 0. This is what you need to remember here. Or non-ideal solutions are those solutions which will not obey the Raoult's law, hence the interaction between the solute and the solvent is not equal. Clear? Done. Next, types of a non-ideal solutions. We have two types of non-ideal solution. One with a non-ideal solution with a showing positive, means positive deviation will be there, and one more non-ideal solution with a negative deviation. Let us check it out. We have a graphs also for this. Okay. Now, non-ideal solution positive deviation means positive deviation occurs when total vapor pressure for any mole fraction is more than what is accepted according to the Raoult's law. According to the Raoult's law. Now, what is a positive deviation? It's going to occur. Positive deviation is going to occur when total vapor pressure for any mole fraction. Total vapor pressure for any mole fraction. Okay. Vapor pressure the total. Yav mole fraction to example XA, XB. Any examples you can take it, okay, is more what is accepted according to the Raoult's law. Means what the Raoult's law will be connected one point, okay. Like example, your teachers will be knowing your value, okay. ನಿಮ್ಗೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ಬೀಳುತ್ತಂತ ನಿಮ್ಮದು ಈಗ ಇನ್ ಕೇಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಒಂದೇ ಕಾಲೇಜ್ನಲ್ಲಿ ಇದ್ರಪ್ಪ, ಒಂದೇ ಕಾಲೇಜ್ನಲ್ಲಿ ಇದ್ದ ತಕ್ಷಣ ನಿಮಗೆ ವ್ಯಾಲ್ಯೂ ಅವ್ರಿಗೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ಟೀಚರ್ಗೆ ನಿಮ್ದು ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳಬಹುದು ಅನ್ನೋದು, ರೈಟ್. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ದೇರ್ ಮೈಂಡ್ ಸೆಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ 88% ಇಸ್ ಬೀನ್ ಡನ್ ಫ್ರಮ್ ದಿಸ್ ಪರ್ಸನ್, ಆಯ್ತಾ. ಸೊ ಈಗ 88% ಆ ಪರ್ಸನ್ ಇಂದ ಬರ್ತಂತ ಟೀಚರಿಗೆ ಗೊತ್ತು, ಆಯ್ತಾ. ಬಟ್ ಇಟ್ ಹಿಯರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್ ಮೋರ್ ದೆನ್ ಮೀನ್ಸ್ ವಾಟ್ ಯು ರಿಟನ್ ಮೋರ್. ಸೊ ಮ್ಯಾಮಗಂತೂ 88% ಇತ್ತು, ಬಟ್ ನಿಮ್ದು ಎಕ್ಸೆಪ್ಟೇಷನ್ ಜಾಸ್ತಿ ಆಯಿತು ಬಿಕಾಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ಕೇಮ್ ಈಸಿ, ದೆನ್ ಯುವರ್ ಪರ್ಸೆಂಟೇಜ್ ಬಿಕೇಮ್ 92. ಇಟ್ ಮೀನ್ಸ್ ವಾಟ್ that is what is more than what is accepted according to the Raoult's law, okay. According to the Raoult's law, in the positive deviation, the total vapor pressure for any mole fraction is more than what is accepted by the Raoult's law. Done. Next, this happens when the new interactions are weaker than the interactions in the pure component, okay. When it is going to happen, this is going to happen when the new interactions are weaker than the interactions in the pure components, clear. So only AB connection means what solute solvent connection is actually less than AA connection and is actually less than AA, and AA interaction means solute-solute interaction and solvent-solvent interaction, clear. Understood? So what happens here, when the new interactions are weaker than the interaction in the pure solvent, for that purpose only A minus B means interaction between the solute and solvent particles is very less compared to the solute-solute interaction and solvent-solvent interaction. This much you should remember. It's enough, okay. Next comes what? That is what? Delta H is going to be what? Positive sign. Delta V is going to also positive sign. So delta S is going to be the positive. So VP observation means observed means what? Once it became more, no, I told you, no, ನಿಮಗೆ ಜಾಸ್ತಿ ಪರ್ಸೆಂಟೇಜ್ ಆಗಿಬಿಡ್ತಪ್ಪ, ಆದರೆ ಆ್ಯಕ್ಚುಲಿ ಟೀಚರ್ ಏನು ತಿಳ್ಕೊಂಡಿದ್ಲು 88% ಆಗುತ್ತಂತ, ಬಟ್ ನೀವು ಎಷ್ಟು ಮಾಡಿದ್ರಿ 92% ಮಾಡಿದ್ರಿ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಅಬ್ಸರ್ವ್ ಪರ್ಸೆಂಟೇಜ್ ಇಸ್ ಹೌ ಮಚ್ 98%, 92%, okay, and accepted percentage is how much 88%. So that's what it's actually observed percentage is more compared to the accepted percentage. Easy to remember, okay. So that purpose only vapor pressure or pressure of A is actually greater than the PA naught, and same way into the mole fraction and PB. This is very important to remember, okay. Idnashne ನೆನಪಿಟ್ಕೋಬೇಕು. Done. So for this is how the non-ideal solution in the positive deviation it shows, how it shows. Clear? Now next, it forms the minimum boiling isotopes. For example, C2H6OH plus cyclohexane. Then the H bonding present in the pure C2H6OH are cut off on adding the cyclohexane. It's actually cut off by on adding the cyclohexane. Then for such solution, delta V and delta H are positive. So such solution, delta H and delta V are positive. Clear? So examples what it comes: acetone plus carbon disulfide, acetone plus benzene, and carbon tetrachloride plus chloroform or toluene. And next comes methyl alcohol plus water and acetone plus C2H5OH for all the positive deviation. Clear? Which will not obey the Raoult's law, which will not obey the Raoult's law. Here the AB interaction means what? Solute solvent interaction is always less than the solute solute and solvent solvent interaction. Clear? This is the means main focused points which you need to remember, okay. This is the graph according to the mole fraction, how the graph is going to happen, okay. If in case if the mole fractions are XA is equal to 0 and XB is equal to 1, and it starts increasing, okay, it starts increasing and slowly it starts slightly bends, okay. Same way it's happening at the XA and XB at the left side of the mole fraction. Means what? Two mole fractions they have. According to that, they are going to get the graph in this way. Then in this way we will get it. With that we will have an idea that V total is actually more compared to the PA and PB. That's what I said you. Clear? Done. Observation is actually greater, means ನಿಮ್ಮ percentage ಜಾಸ್ತಿ ಬಂದಿತ್ತು, ಬಟ್ ನಿಮ್ಮ ಟೀಚರ್ ಎಕ್ಸೆಪ್ಟೆಡ್ ಎಷ್ಟಿದ್ಲು 88% ಬೀಳುತ್ತಂತ ತಿಳ್ಕೊಂಡಿದ್ಲು, ಬಟ್ ನಿಮ್ಮ ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟಾಯ್ತಪ್ಪ? ಯು ಗಾಟ್ ಅ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ 92. Clear? Next, non-ideal solution showing the negative deviation. Okay, what happens here? Negative deviation is seen when the total vapor pressure for any mole fraction is less than the accepted from the Lorentz law. Okay, so yavag negative deviation agutte whenever the negative deviation is happening. Negative deviation is seen when total vapor pressure for any mole fraction is less than accepted from the Raoult's law. Opposite of the positive deviation. Okay, ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ ನಾವು ಆಕ್ಚುಲಿ ಅಬ್ಸರ್ವೇಷನ್ ಏನು ಮಾಡಿದ್ವಲ್ಲ, ಈಗ ನೋಡಿ ಟೀಚರ್ ನಿಮಗೆ 88% ಮಾಡ್ಕೊಂಡಿದ್ಲು, ಎಕ್ಸೆಪ್ಟೇಷನ್ ಇಟ್ಕೊಂಡಿದ್ಲು, ಬಟ್ ನಿಮಗೆ 92% ಆಯಿತು. ಯಾವಾಗ? ವೆನ್ ದ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ is actually having a, one second guys. Okay, so non-ideal solutions actually which is showing a positive deviation. So in negative deviation alli enagutte enen actually percentage ma'am accept ಮಾಡಿದ್ರಲ್ಲ 88%, but ಆ ಹುಡುಗ ಎಲ್ಲಾರ ಹುಡುಗಿ ಎಂತ ಎಷ್ಟು ತಗೊಂಡ್ಬಂದ್ಲು 85% ಆಗಿಬಿಡ್ತಪ್ಪ. means what? She had accepted more, but absorption vapor is actually more there compared to the accepted one. Okay, ಎಷ್ಟು observation ಇತ್ತು ಅವ್ರದ್ದು? ಆಲ್ಮೋಸ್ಟ್ ಆಫ್ 88%. okay, but ಎಷ್ಟು ಆಯಿತು? ಆಕ್ಚುಲಿ 85% ಆಯಿತು. that is what actually the of the non-ideal solution which was showing the negative deviation. Clear? So positive deviation ನಲ್ಲಿ ಏನು ಎಕ್ಸೆಪ್ಟ್ ಮಾಡಿರ್ತಾರಲ್ಲ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿನೇ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ deviation ಅಲ್ಲಿ ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಆಗುತ್ತೆ. this much remember. okay, now this happens when new interactions are stronger than the interactions in the pure components. Like A, that's what. Opposite of that means obviously there it was a increasing. So this was decreasing. AB means interaction between the solute and solvent was decreasing in the positive deviation. But here the A means solute and solvent interaction is actually increasing compared to the solute and solvent. Done? So delta H is equal to negative sign and delta V is equal to negative sign. So delta S is also going to be positive sign. So VP absorption is actually less than VP accepted. So that is what you need to remember. Difference between both the things also will be easy to remember. Done? Next. It forms maximum boiling azeotrope, for the example CHCl3 plus CH3, COCH3, and for such solution delta V and delta H are a negative. Delta V and delta H are going to be the negative. Clear? So ಎರಡೂದ್ರಲ್ಲಿ non-ideal solution of a negative deviation, always remember delta H and delta V will be in the form of a negative sign. Clear? So LL negative sign idella, easily you can recognize that it's a non-ideal solution which will not obey the Raoult's law, plus it is going to be the negative deviation. Clear? Yes. So this is what simple example also they have given about the hydrogen bonding, how it's been happening. Clear? So example, chloroform plus benzene or diethyl ether. This is a separate word. Okay, diethyl ether. Second comes acetone plus aniline and nitric acid, that is HNO3 plus water. Fourth one, acetic acid and pyrimidine. So these are the few examples which we can give it for the non-ideal solutions in the negative deviation. Next comes azeotropic mixture. So what is the meaning of an azeotropic mixture? It is a mixture of two liquids which are having the same boiling point. Okay, ಈಗ ಎರಡು ಮಿಕ್ಸ್ಚರ್ ತಗೊಂಡಿದ್ದೇವೆ. ಓಕೆ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದರಲ್ಲಿ ನಾನು ಶುಗರ್ ಮತ್ತೆ ನೀರು ತಗೊಂಡಿದ್ದೇನೆ, ಇನ್ನೊಂದರಲ್ಲಿ ಶುಗರ್ ಮತ್ತೆ ಸಾಲ್ಟ್ ತಗೊಂಡಿದ್ದೇನೆ. ಓಕೆ, ನಾವು ಈಗ ಎರಡು ಕಡೆ ಟೆಂಪರೇಚರ್ 200 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಹಾಕಿದೆ. ಸೊ ಎರಡು ಕಡೆ 200 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಹಾಕಿದ ತಕ್ಷಣ ಏನು ಬಾಯ್ಲಿಂಗ್ ಆಗುತ್ತಲ್ಲ, ಟೆಂಪರೇಚರ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಸೇಮ್. ಓಕೆ, ಟೆಂಪರೇಚರ್ ಸೇಮ್ ಇದೆ. ಆವಾಗ ಇಸ್ ಇಟ್ ಟ್ರೂ ದಟ್ ದ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ಸೇಮ್ ಫಾರ್ ಬೋತ್ ದ ಥಿಂಗ್ಸ್? No, right? So where the boiling point is same, even after applying the same temperature, those all mixtures are going to be azeotropic mixture. Done? So because of the same boiling point, the two liquids cannot be separated by a simple distillation. Okay, so atra salvagine that can be not be separated easily. So separate madlike ಸ್ವಲ್ಪ difficult ಆಗುತ್ತೆ ಆ time ನಲ್ಲಿ. So that is actually a simple, means we can do it from the simple distillation. Okay, next, these mixtures are therefore called as a constant boiling mixtures, obviously because at constant temperature both will give the mixture. No, completely it will get mixed at same temperature itself. So that is called as a constant boiling mixture. Done. So these are formed by non-ideal solutions. Matte yavaga isotropic mixtures madutte almost where they are non-ideal solution. Means what? It will not obey the Raoult's law. So this is only for non-ideal solution. Okay. This is only for non-ideal solution, and here the non-ideal solution which is there, that will not obey the Raoult's law. Those will not obey the Raoult's law. Done. Now, isotropic mixture and composition curves. So, what is the meaning of a composition curves now? Okay. So, these are the mixture of two liquids which boils at one particular temperature. So, these are the mixtures of two liquids, okay, and which boils at one particular temperature, which will boil at what? One particular temperature. Done. Like a pure liquid and distills over in the same composition. That is, these are constant boiling mixtures. These are constant boiling mixtures, and these are formed by non-ideal solution. So how they are formed? It's formed by non-ideal solution. Clear? So these are the mixtures where the two liquids which are at boiling. I told you constant boiling wala thing, that two liquids which boils at one particular temperature like a pure liquid, and that liquid is distills over in the same composition. Same composition andrenalli adrinallene composition nalline form agutte. Clear? And then these are the constant boiling mixtures, and these are formed by non-ideal solution. So these are constant boiling mixture. These are constant boiling mixture antara karitare, because at the same composition both the liquids are getting boiling points are same for both the solutions. Clear? So these are the constant boiling mixtures, and these are formed by non-ideal solutions. So ella edral form agutte, bare non-ideal solutions alli ashte agodu, not in ideal solution. As we know that ideal solutions are obeys the Raoult's law, non-ideal solution will not obey the Raoult's law. Clear? For that purpose, we should be completely focused on which type of ideal solution it is. Okay, whether it is going to be the ideal solution or non-ideal solution. In a non-ideal solution, whether it is going to be a positive deviation or it's going to be the negative deviation. Then only we are going to get the clarity about it. Okay. Yes, so this is the easiest way. Like I told you people, like flowchart plays a very important role. Okay, flowchart plays a very important role. So, ee tara nimagon sample tosidene, you people can plan your flowcharts like this. Okay, let's see. Now, if you want to know about the Raoult's law, as we know that in this chapter, Raoult's law is very, very important. Okay, solution nalli Raoult's law 100% sure. KCET mele ee topic mele 101 question antu 100% sure anta ಹೇಳಿದ್ದಾರೆ already, and it will come, guys. So, ಈಗ ನಿಮ್ದೇನ್ ತಲೆ ಓಡಿಸಬೇಕು? ಈಗ ಯಾವಾಗಾದ್ರೂ Raoult's law ತೆಗೆದು ನೋಡಿದೆ ಅಪ್ಪ. ಓಕೆ, ನಾ ಯಾವುದೋ ಒಂದು PYQ ಬುಕ್ ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೇನೆ, ಅದರಲ್ಲಿ ಚಾಪ್ಟರ್ ಸೊಲ್ಯೂಷನ್ ಐ ಆಮ್ ಲರ್ನಿಂಗ್ ಇಟ್, ಚಾಪ್ಟರ್ ಸೊಲ್ಯೂಷನ್ ನಂದು ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸ್ ಬಿದ್ದಿದ್ದಾರೆ ಅವನ್ನೆಲ್ಲ ಕುಂತು ನಾನು ಬರೆಯೋಳದೇನಪ್ಪ, ಸಾಲ್ವ್ ಮಾಡೋಳದೇನೆ. ಸೊ ನನಗೀಗ ರಿವಿಷನ್ ಮಾಡೋದಿದೆ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು. ಸೊ ರಿವಿಷನ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ಇದನ್ನ ಜಸ್ಟ್ ನೋಡ್ಕೊಂಡ್ಬಿಟ್ರೆ, ಈ ತರ ಒಂದು ಏನಾದರೂ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನೀವು ಖುದ್ ನಿಮ್ಮದು ಏನಕ್ಕಂತ ಹೇಳ್ತಿದ್ದೇನೆ ನಾನು, ಬಿಕಾಸ್ ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ನೀವು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನೀವೇನು ಬರೀತಾರಲ್ಲ, ನೋಟ್ಸ್ ಮಾಡ್ತಾರಲ್ಲ, ದಟ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಯು ವೆನ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ದ ರಿವಿಷನ್. ಸೊ ಯಾರ್ದೋ ಬೇರೆದವ್ರು ತಗೊಂಡ್ಬಂದು ನಾವು ಕಾಪಿ ಪೇಸ್ಟ್ ಮಾಡಿ ಅದನ್ನ ನಾವು ಓದ್ತೇನಂದ್ರೆ ಕುಂತು ಆಗಲ್ಲ. ಆಯ್ತಾ? ಯು ನೀಡ್ ಟು ಡೂ ಇಟ್ ಬೈ ಯೋರ್ ಓನ್. Clear? So this is just a sample to remember how the reactions are going to happen in the Raoult's law. Done. And Henry's law is also present here. Henry's law means I'll just quickly tell you, at a constant temperature, the amount of the given gas that will dissolve in a given type of a volume of a liquid is directly proportional, whatever it is present, but it should be in a liquid, and directly proportional to the partial pressure of the gas in equilibrium with that liquid. In equilibrium with that liquid. So same like that only, there is a vapor pressure also, that is V total is equal to VA, PA plus PB. That is PA is actually equal to mole fraction of XA and mole fraction of XB. Clear? Means they are given the value of the both the things. ಎರಡು ಥರದ್ದು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ, according to the total. Done. So Means this is just a simple sample which I have given you. You can also try it out. It will help you people a lot. Okay. Let's start with the next part. That is going to be types of azeotropic mixture. Clear? Types of azeotropic mixture. Let's start. So these are the following two types: azeotropic mixtures with minimum boiling point. So azeotropic mixture with a minimum boiling point, what actually there happens? So azeotropic mixture is the mixture of two liquids in which the boiling point of the mixture is lesser either of the two pure components. That's what it is, lesser, and it will be same itself. Okay. Then it is formed by the composition of non-ideal solution, which shows the positive deviation to the solution having a maximum vapor pressure. It's having a maximum vapor pressure, and it will show only in the positive deviation. It will show in the positive deviation. Next, this mixture consists of non-ideal solution. This mixture contains of non-ideal solution showing positive deviation, and that Raoult's law for which the vapor pressure is a mixture. Vapor pressure is a mixture. Example, C2H5OH at 95.5%, H2O 4.5% mixture, which will boil at 351.5 Kelvin. 351 Kelvin, 5 Kelvin. So what happens with the boiling point of that? See, you can check it out. Boiling point of C2H5OH is actually 78.1 degrees Celsius. Clear? So boiling point for H2O. Boiling point for H2O is actually 100 degrees Celsius. That's, we know it, right? Now, such mixtures on distillation will give the first fraction up to m in the pure state. Okay, up to m in the pure state. Then after this, the temperature will raise and the second component will pass over. So if the temperature will raise, then the second component will come. Why? Because that component's work is done. Then second component will come into the line, right? So once that is also done, third component will come. Depends on what type of a solution we have taken. Okay. So next, hence in such solutions also complete the separation is not possible. So complete separation is not at all possible in most of the cases. That we needed very high-tech laboratory ಬೇಕದಕ್ಕೆ. Okay, high-tech laboratory ಅಂದ್ರೆ ಏನು, ಅಲ್ಲಿ ಏನೇನು ಆಗ್ತಿದೆ ಏನೇನು ಬಿಡ್ತಿದೆ ಏನೂ ಗೊತ್ತಾಗಲ್ಲ, ಆ ಟೈಪ್ ಆಫ್ ಇರುತ್ತೆ. ಸೊ ಅದು ಅಂಥವೆಲ್ಲ ಬೇಕು ಅಲ್ಲಿ. ಓಕೆ, ಅಕ್ಯುರೇಟ್ ಆಗಿ ಬರಬೇಕಂದ್ರೆ. ಸೊ ನೆಕ್ಸ್ಟ್, the figure shows a maximum vapor pressure at which, one second guys. Yes. Next comes azeotropic mixture with the maximum boiling point. So first one is done, that is azeotropic mixtures with minimum boiling point. Now comes the maximum boiling point. So what happens here? The azeotropic mixture is the mixture of two liquids in which the boiling point of the mixture is larger. So boiling point of the mixture is what? Larger than the either of the two pure components, So it is formed by the composition of a non-ideal solution, which shows negative deviation to the solution. Which will show what? Negative deviation to the solution, which are having a minimum vapor pressure. Clear? So example, nitric acid, that is 68%, plus water, that is 32% mixture, boils at 393.5 K. Okay, ಇದು ಎಷ್ಟು ಆಗ್ತಿದೆ ನೋಡಿ, nitric acid ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, 68% ಕೊಟ್ಟಿದ್ದಾರೆ, right? So now water they have given 32%. Okay, now it is boiling at how much? 393.5 kilo. Okay, Kelvin. Now an aqueous solution of HCl initially gives the pure water whenever we are subjected to the distillation. So whenever we are subjecting to the distillation, we'll get the pure water. Okay, later forms the constant boiling mixture at the temperature of 100 degrees Celsius, which is containing 20.24% of acid. So slowly this boiling mixture of the temperature will be coming to the 100 degrees Celsius. Then what happens? It will be containing 20.24% of an acid. Clear? Next comes during distillation, whenever the two volatile liquids, that is A and B, are mixed. Okay, for condition having a A is more volatile and present in a axis. So the vapor part will be richer in component A and liquid part will be for component B. Lastly, A point is reached N, where the boiling point is a maximum and the vapor pressure is the minimum as shown. Okay. Now for this stage, from this type of a solution, complete separation of the components into this pure state is impossible. Same as we have learned it in the azeotropic mixture with the minimum, means minimum boiling point. What was that? Which we have learned it here. This which we have learned it, minimum boiling point. Maximum, it's just completely impossible to separate. Okay, we can't do a pure substance. Pure mixture is not possible with this method. Clear? Next comes what? Mixture showing the ideal behavior or zeotropic mixture. It is also showing ideal behavior or zeotropic mixture. So what is the meaning of that now? So zeotropic mixture is defined as the liquid mixture which get distilled when there is a change in its concentration. So when it will change? When there will be a change in the concentration. But actually what? We know that non-ideal solution, at least completely, whether you are changing the temperature, not changing the temperature, we are applying temperature and pressure more also, it's of no use. What we need actually there, it will not obey only the Raoult's law, guys. So no use of thinking those things. Okay. So here for azeotropic mixture, the vapor pressure composition curve for liquids A and B and is in always straight line, and A will be collected, distilled at it become more volatile on distillation. So when you start distillating, it will become more volatile. Clear? So now the remaining fraction will be richer in the B and the poorer in the A. We can get a A and B in their pure state on repeating the process of distillation again and again. Like example, methanol and water mixture. So methanol and water mixture mein how much ever you are doing those things. Okay, how much ever you are removing the things and you are adding up the pure component you wanted. But also some amount of H2O will be left out in the methanol. Clear? That's what I'm trying to tell. It's just completely impossible to get a pure component so easily. Done. So this is all about the azeotropic mixture. Done. So now we got to know about the azeotropic mixture. We got to know how the ideal and the non-ideal solutions are working out, and after that we got to know about the non-ideal solution in a positive deviation and a negative deviation. Then let's move to the solubility of partially miscible liquids. So what happens in a solubility of partially miscible liquids? It will conjugate the solution. It will conjugate the solution. So many liquids are partially miscible and forms the two liquids. It will form what? It will form the two liquids. One second, guys. Yes. So many liquids are partially miscible and from two liquid layers at a particular temperature. Such liquid solutions in which the different composition of different components coexist are called conjugate solutions. So there will be a liquid solution in which there will be a different composition of the components, plus it will have actually a particular temperature. So such liquids are actually called as conjugate solution. Okay. So different composition of components irutte. Different composition andre ondralli solid liquid irutte, ondralli liquid ಮತ್ತೆ gas irutte. Composition ಬೇರೆ ಇದೆ ಎರಡತ್ರದ್ದು. Okay. But if in case different composition ಇದೆ, but the components of the coexist, they will coexist with each other, are called as conjugate solution. Clear? So conjugate solution is also important, guys, in all the prospective view, whoever it is seeing. Next comes the critical temperature. So what is the meaning of a critical temperature? So with a change in the temperature, the miscibility of the liquid changes. So that liquid's means thickness will actually start changing it. Okay, how it will start changing? Critical temperature means the temperatures, if you are increasing it, okay, you are increasing the temperature, sometimes what happens, the solution's concentration will be in a different way. Okay, so depends on that only the temperature will be increasing and decreasing, because both the concepts will be happening there. Exothermic also will be happening, endothermic also will be happening, but depends on what type of a solution we have taken it. Okay, so only with a change in the temperature, the miscibility of the liquids will change. For a certain temperature, the two layers becomes completely miscible, and this certain temperature is termed as critical temperature. Okay, or it is also called as consolidate temperature. So this certain like layers will become completely miscible, that this certain temperature, at what temperature this has become, that temperature is called as what? Critical temperature or consolidate temperature. Means what? I am right now, I'm critically ill. I am right now in what stage that we can't speak also, we can't do anything in that stage. That is called as critical one. Okay, same way here also the condition will be was possible. Okay. Next comes the colligative properties. So the properties of a solutions which depend only on the number of particles. It depends on the number of particles like a molecules or ions of a solute in a definite amount of the solvent. So whatever the number of particles like molecules or the ions of a solute. Like example, we have taken an example as sodium. So our sodium nalli ಎಷ್ಟಪ್ಪ ion ಇದೆ? ಒಂದಿದೆ ion. So ion ಏನಿದೆಯಲ್ಲ, that will definitely have a amount of the solvent also. Definite amount of solvent also, but not on the nature of the solute, but it will not depend on the nature of the solute. Okay, it will depend only on the number of the moles or an amount of that, but number of the particles will depend agutte, not on what is actually, whether it is a solid, liquid, gas, aqueous medium, dilute solution, concentrated solution, nothing matters to them. Just the matters is what? Number of particles like molecules. Clear? So this number of particles, how much it is important in the colligative properties, not the what type of a state they have used, whether solid, liquid, gas, aqueous, concentrated, doesn't matter to them. Clear? These all are called as what? Colligative properties. So what are these colligative properties now? So, relative lowering of the vapor pressure will be there, osmotic pressure will be there, elevation in boiling point, depression in the freezing point, VP, BP, there is vapor pressure, boiling point, freezing point, melting point, and osmosis are not colligative properties, and these are the properties of dilute solution and non-volatile solute without any dilution of the association, So, this is very, very important. On this also, they asked a lot of questions in KCET. Clear? So, idr melenu KCET mele questions jaasti keltare. Colligative properties ಮತ್ತೆ ಅದರದ್ದು properties ಏನಿದೆ ಅದರ depth ನಲ್ಲಿ ನಿಮಗೆ already ಇದೆ NCERT ನಲ್ಲಿ ನೀವು ಓದಿರಬೇಕು ಅದನ್ನ, right? Yes, relative lowering of vapor pressure. So now one by one all these things will be learned. All the things means only till fourth one we are going to learn. Okay. So relative lowering of vapor pressure. When a non-volatile solute is being mixed with a volatile solvent. So non-volatile solute ಏನಿದೆ ಅಲ್ಲ ಅದು ಎದರ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗಿದೆ? Non-volatile solute is got mixed with volatile solvent, and the vapor pressure of the solution will become less than the vapor pressure of the pure solvent. It will become less than the vapor pressure of the pure solvent. So it is due to the increase in the density which will decrease the rate of the evaporation. Density will be decreasing, so for that purpose rate of the evaporation will also start decreasing. Rate of the evaporation why it will start decreasing? See, ಈಗ density ಜಾಸ್ತಿ ಆಕೊಂತ ಹೋದ್ರೆ temperature ಎಲ್ಲ ಕಡೆ reach ಆಗ್ಲಿಕ್ಕೆ time ತಗೊಳುತ್ತೆ, right? So ಆ temperature ಏನು reach ಆಗ್ಲಿಕ್ಕೆ time ತಗೋತಲ್ಲ ಅವಾಗ this rate of evaporation will get slow, means what? It starts decreasing. Evaporate ಆಗಿ ಹೋಗೋದು ಬಹಳ ಲೇಟ್ ಆಗುತ್ತೆ, because temperature ಸರಿ ಟೈಮ್ ದಲ್ಲಿ ಅದಕ್ಕೆ ಹತ್ತತಿಲ್ಲ. Done? So this much you should remember in the relative lowering of the vapor pressure. So mathematically how they will do it? So pi is equal to, pi is inversely proportional to 1 by root d, 1 by root d, where P naught is going to be the vapor pressure of the pure solvent, P will be the vapor pressure of the solvent in solution. So relative lowering of vapor pressure nalli, that is pi is inversely proportional to 1 by root d, main thing. And the density, when you start increasing the density, what happens with the rate of evaporation? It will also start decreasing. This one statement also you should remember. Done. This concept is also very important. Next. So in a dilute solution, N is a far greater than the N, and hence XB is equal to N divided by capital M. N is equal to W divided by M, and W divided by capital M. So is equal to what? WM divided by WM. Here W is going to be the weight of the solvent, small w is going to be the weight of the solute, and capital M is going to be the molecular weight of the solvent, small m will be the molecular weight of the solute. It will be what? Molecular weight of the solute. Clear? This is also very important. We use this formula for the purposes of problems. Okay. Next comes, so PA naught minus PA is equal to P naught A is equal to delta P divided by P naught, and WM divided by WM. M is going to be the molecular weight. M is going to be the molecular weight of that, and small m is going to molecular weight of the solute. As we know that M will be more, so we will name it as capital M. In that way we can remember it easy way. Easy, some easy tricks there. Okay. Next, the molecular weight of the solute can be determined with the help of the relative lowering of a vapor pressure method. Okay. Now, this relative lowering of a vapor pressure is being measured by Ostwald-Walker method. Which method they are using it? Ostwald-Walker method. This is important. In KCET they have asked it. Okay. Next, P naught minus PS divided by P naught, where the loss of the mass of the solvent bulbs divided by gain in the CaCl2 tube. So, osmosis means what now? Okay, we are done with the RLVP, that is relative lowering vapor pressure. So, in relative lowering vapor pressure, what you should remember, I said you. So, in that way, na yen nenapittukolli anta ಹೇಳ್ತಿದ್ದೇನಲ್ಲ ಅದನ್ನೆಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ book ನಲ್ಲಿ easy ಆಗುತ್ತೆ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. Okay. Osmosis. So next comes the osmosis. Here there is a net flow of solvent molecules from less concentrated solution to the more concentrated solution, or from the solvent to the solution, or from the solvent to the solution, or across a semi-permeable membrane, or across a semi-permeable membrane, where membranes of animal origin and membrane made form. So membranes of animal origin also is there, and membrane made from the human also it is there. Okay. So this is simple examples which we can give it for the osmosis. Next becomes the osmotic pressure. So what is the meaning of an osmotic pressure? So on osmotic pressure also they have asked many times in the KCET. So just concentrate here properly everyone. Okay. Now when the column is being formed as a result of osmosis, then the equilibrium hydrostatic pressure is known as osmotic pressure. So what is the column which is being formed as a result of osmosis? In column form ಆಗಿರುತ್ತಲ್ಲ ಅದಕ್ಕೆ result of osmosis ಅಂತ ಕರೀತಾರಲ್ಲ ಅವೆಲ್ಲ they all are equilibrium hydrostatic pressure. ಅವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? Equilibrium hydrostatic structure. Okay. Equilibrium hydrostatic pressure. So that is known as what? Osmotic pressure. That's what I said, it is important. Clear? Next, to restrict the entry of the solvent into the solution through the semi-permeable membrane, the minimum pressure that is to be applied to the solution is osmotic pressure. So, in case now semi-permeable membrane, the U-shaped membrane in the semi-permeable membrane in the left side in the anode in the cathode ge ಬರೋದಿದೆ ಲಿಕ್ವಿಡ್ ಅದನ್ನ ಸ್ಟಾಪ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯಾವ ತರ ಪ್ರೆಷರ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೇವಲ್ಲ ನಮ್ಗೆ ಈಗ ಏನೇನ್ ಆಗ್ಬೇಕು ಈಗ ತಿಳ್ಕೊಳ್ಳಿ ನಾವು ವಿ ಆರ್ ಆಕ್ಚುಲಿ ಡೆಪಾಸಿಟಿಂಗ್ ಆನ್ ದ ಐರನ್ ದ ಗೋಲ್ಡ್ ಓಕೆ ವಿ ಆರ್ ಡೆಪಾಸಿಟಿಂಗ್ ದ ಗೋಲ್ಡ್ ಆನ್ ದ ಐರನ್ ಪೀಸ್ ಸೊ ನಾವು ಎವ್ರಿಥಿಂಗ್ ಹ್ಯಾಸ್ ಬೀನ್ coated ಓಕೆ ಕಂಪ್ಲೀಟ್ಲಿ ಕೋಟಿಂಗ್ ಆಗಿದೆ ಓಕೆ ಐರನ್ ಪೀಸ್ ದು ಕಂಪ್ಲೀಟ್ಲಿ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಆಗಿದೆ ನಾವು ವಿ ವಾಂಟ್ ಟು ಸ್ಟಾಪ್ ಇಟ್ ಓಕೆ ನಾನು ಸ್ಟಾಪ್ ಮಾಡ್ಲಿಕ್ಕೆ ಏನ್ ಆಸ್ಮ್ಯಾಟಿಕ್ ಪ್ರೆಷರ್ ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ ಅದಕ್ಕೆ ಏನ್ ಪ್ರೆಷರ್ ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ ಅದಕ್ಕೆ ಆಸ್ಮ್ಯಾಟಿಕ್ ಪ್ರೆಷರ್ ಅಂತ ಕರೀತಾರೆ ಡನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ yes so it is a minimum pressure needed to apply on the solution for making its vapor pressure equal to the vapor pressure of the solvent clear so it is denoted by P or pi and it is measured by Pfeffers method or Beckley-Hartley's method. So Townsend's method. So this is measured by these all methods. Clear? It is measured by many methods also. Next comes the Van 't Hoff's equation of osmotic pressure. Van 't Hoff's equation of osmotic pressure. Still we have lot of things to learn. Okay. So pi is equal to CST, Van 't Hoff's equation of osmotic pressure, where pi is equal to CST. Here pi is equal to osmotic pressure and S or R is going to be the solution constant. S or R is going to be what? Solution constant, where it is going to be equal to almost 0.0821 liters per atom per atm kilo method. Means what? At constant temperature and pressure, how much it is there? That much. Okay. Now C is going to act like what? Concentration of the solution in mole per liter, and T will be the absolute temperature in the K. For that purpose, this Van 't Hoff's equation is very important to learn. Understood? Yes. So pi is directly proportional to C, that is at constant temperature. So the pi is equal to N divided by V ST, where C is going to act like what? N divided by V. Okay, ಇಲ್ಲಿ just ಅದನ್ನ substitute ಮಾಡಿದ್ದಾರೆ. Done? ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ ಸಿ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದಾರೆ ಸಿ ವ್ಯಾಲ್ಯೂನ pi is equal to C value is N divided by V and remaining things that is S and T is been kept like that only. Clear? Kept like that only. Then next pi is equal to means they have taken this V here, that is going to be the pi V is equal to NST. Then where N is the number of the moles of a solute and V is the volume of the solution and S is going to, you know already what is S or R, solution constant there. S and R are going to be solution constant and T will be the absolute temperature in K. Absolute temperature in K. Done. Now why V is equal to, pi V is equal to, okay, W divided by M. Why W divided by M? N is equal to what? N is equal to what? Yeah. Or else. Okay. So this is what they have substituted it here. Done. And RT. Then RT. Then. So N is equal to W divided by M and M is the molar mass of the solute. W is the gram weight of the solute. Now determination of that molecular weight from the osmotic pressure. According to the osmotic pressure now, pi is equal to CST, we know it from here. C is equal to N divided by, we got to know where the C is going to be the concentration of the solution, whole solution. N is going to be the number of the moles of a solute in a solution, and when the solute is being dissolved in the V liter. So V liter nalli dissolve ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, that time everything will be same, just we are going to substitute the N value and V value. Clear? So pi V is equal to NST as we know it according to the Van 't Hoff's factor. Clear? So pi V is equal to N value is W divided by M. That's what we will substitute it here. 1 second. Yes, this will substitute it here. Done. So m is equal to, now we need to get to know the m. Why? Because we need to find the molecular mass. What is happening when, that is m is going to the molar mass of the solution. We need to find the molar mass of the solution. ಏನು changes ಮಾಡೋದಿಲ್ಲ. ಏನು find ಮಾಡೋದಿದೆ ಅದನ್ನು LHS ಕಡೆ ತಗೊಂಡು ಬಂದ್ಬಿಡಿ. Simple. Okay. m is equal to w into st divided by this pi is there, that will come down. Okay. That is going to be the pi into v. Clear? Means this m, I'll write the step here. m is equal to, em ಏನಿದೆ ಅಲ್ಲ ಅದು ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ. This m is going to come this side. So that is what we have written it. And this will go this side. That will go here. So m is equal to w into st divided by pi into v. Pi into v. Done. So accurate molecular weight is being obtained under the following condition. How the accurate molecular weight is being obtained means, to find the molar mass of that component, how we are going to find? By using this formula, where m is equal to w into st divided by pi into v. Clear? So this is important. This numerical problems irutte idra mele. This is important. Numerical problems irutte idra mele. Clear? Now, what are the factors? Means accurate molecular weights which has been obtained under few conditions. What are those conditions? Solution must be very dilute. Solute must be non-volatile. Solute must be non-volatile. And solution must be very dilute. Means solution nalli concentration ಏನು ಇರಬಾರ್ದು, completely it should be diluted. ಮತ್ತೆ ಯಾವ solute ತಗೊಂತಿದೇವಲ್ಲ ಆ solution ನಲ್ಲಿ that should be a non-volatile. Okay, it should be a non-volatile. Next, solute should not undergo dissociation or association in the solution. Understood? Next comes what? When height has been involved, then pi is equal to HDG. This also you should remember, okay, while solving. Means sometimes they'll ask the problems regarding this, like what is the height, like pi, how it will, you are going to recognize this. We know it is a 3.142, but also it's like when you are going to use what is actually the pi, if in case they are given the value of the h or they have given the value of the d or g, that time you need to use this formula. Clear? Where the d is going to act like a density of the solution and h is going to be the height difference in both the vessels due to the osmosis. So you know osmosis, they will use this much big glass containers, okay, to do the osmosis experiments. So might have seen in your labs, in your college labs, ನೋಡಿರ್ತೀರಾ ನೀವು osmotic ಇಷ್ಟು ದೊಡ್ಡ ಗ್ಲಾಸ್ ಬೌಲ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಅದರಲ್ಲಿನೇ osmosis pressure ಮತ್ತೆ ಅಪ್ಲೈ ಮಾಡೋದು, ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಮಾಡೋದು, ಅದರಲ್ಲೇನೆ ಎಲ್ಲ ಆಗೋದು. ಆಯ್ತಾ? So next comes isotonic solution. So solution having equal molar concentration. Solution which is having a equal molar concentration or equal osmotic pressure are called isotonic solution. Are called what? Isotonic solution. So wherever the solution is having equal molar concentration ಇದೆ ಮತ್ತೆ equal osmotic pressure ಇದ್ರೆ ಅವಕ್ಕೆಲ್ಲ isotonic solution ಅಂತ ಕರೀತಾರೆ. ನಾವು ಎಕ್ಸಾಂಪಲ್ ಏನು ತಗೊಳ್ಳೋಣ? 0.91% solution of a pure aqueous NaCl ಇದೆ. Clear? Is isotonic with the human RBC. So human RBC is isotonic ಇದೆ. ಆಯ್ತಾ? Now P1 is actually equal to P2. Has it is only told that molar fractions will be equal and even the osmotic pressures will be equal. So the molar fraction ಮತ್ತೆ equal ಮತ್ತೆ ಇದು equal ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು. ಆಯ್ತಾ? Now W1 divided, we know already P1 is equal to what? W1 divided by M1 into V1 and P2 is equal to W2 divided by M2 into V2. Now here, okay, 1 second guys. So how it's going to be solving? You can solve it directly also. If you don't want it to be extended, then you can keep it in this way itself. Next comes, in an isotonic solution, net osmosis is always be 0 whenever the RBC are placed in the distilled water. So RBC in case distilled water nalli in case store madidare. Okay, then it is also called as hypotonic medium. So they swell as water flows into them, but when they are taken in the 5% NaCl solution, hypertonic solution agutte, they shrink as water comes out from the cells. They will start shrinking it. Like example, how the things we can do it simple way. In your NCERT ನಲ್ಲಿ book ನೋಡಿರ್ಬೇಕು ನೀವು ವಟಾಣಿ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ವಟಾಣಿ ಅಂದ್ರೆ ಗ್ರೀನ್ ಪೀಸ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದಾರೆ ನಿಮಗೆ, ಯಾವ ತರ ಆಗುತ್ತೆ ಸಿಂಕು ಮತ್ತೆ ಯಾವ ತರ ಉಬ್ಬುತ್ತೆ ಅನ್ನೋದು. ಆಯ್ತಾ? ಸೊ ಅದರಲ್ಲಿ ಹೈಪೋಟೋನಿಕ್ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ಏನು? ಉಬ್ಬುತ್ತೆ. ಹೈಪರ್ಟೋನಿಕ್ ಅಂದ್ರೆ ಏನು? ಸಿಂಕ್ ಆಗುತ್ತೆ. ಲೈಕ್ ಅಜ್ಜಿ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಲೈಕ್ ಅಜ್ಜಿ ಮೀನ್ಸ್ ಅಜ್ಜಿ ಸ್ಕಿನ್ ಟೈಟ್ ಸ್ಕಿನ್ ಲೂಸ್ ಸ್ಕಿನ್ ಆಗಿರುತ್ತಲ್ಲ ಆ ತರ. ಡನ್. Next comes elevation in boiling point. So boiling point is the temperature of a liquid at which its vapor pressure becomes equal to the atmospheric pressure. So elevation in the boiling point is what happening? Boiling point in the temperature of a liquid at which its vapor pressure will become equal to the atmospheric pressure. So ಏನೇ vapor pressure ಆಗ್ತಿದೆ ಅಲ್ಲ ಅದು equal ಆಗುತ್ತೆ atmospheric pressure ಜೊತೆ. Clear? Next, elevation in boiling point is also termed as abyloscopy. Elevation in boiling point is also told as abyloscopy. This question also has been asked a lot of times in the PU board plus in the KCET. Okay. Next, it has increases in the boiling point of the solvent due to the addition of non-volatile solute. It is denoted as delta TB also. Means if there is a changes, then it will be mentioned as delta TB. Means boiling point, change in the boiling point. Next comes, it is measured by the Landsberg's method and Coulter's method. Even it is measured by what? Landsberg's method and Coulter's method. So the elevation in boiling point is given as m is equal to molality of the solution and delta P is actually directly proportional to the m, or delta TB is directly proportional to the KB. Means what? That proportionality constant which is there, that will be considered as KB. Means boiling point of that. Okay, boiling point. Next, molecular weight of that solute is going to be mW. That is mW is equal to Kb into W into 1000 divided by delta TB into W. This is very, very important. Idr melenu problems keltare. Next, here W is equal to what? Weight of the solvent. Small w is equal to weight of the solute. Kb is the molar elevation constant or equilibroscopic constant or a boiling constant antanu karibohudu. Next, boiling constant anta karalla because boiling constant is TB. Sorry, TB is a boiling constant. Okay. So if molality of the solution is 1, then molecular weight of the solute, that is mW, is equal to Kb into W into 1000 into delta TB into W. Okay, here W is equal to weight of the solvent, small w is equal to weight of the solute, and Kb is equal to molar elevation constant or equilibroscopic constant. If the molarity of the solution is 1, then delta TB is always equal to the Kb. Means what? Delta TB andre in boiling point idella idu yavaglu equal irutte jode irutte molar elevation constant jode easily equal irutte. Then the Kb is equal to what? RT square divided by L. RT square divided by L. So if you want to find for the LV, okay, ಇಲ್ಲಿ ಅಕಸ್ಮಾತ್ L ಕಂಡುಹಿಡಿದ್ರೆ ಅದನ್ನ ಹೊರಗಡೆ ತಗೊಂಡ್ಬರೋದು, ಉಳಿದಿದ್ದೆಲ್ಲ ಒಳಗಡೆ ಹಾಕ್ಬಿಡೋದು ಅಷ್ಟೇ. So here LV is equal to latent heat of the vaporization. Just we can write it as L also. L is equal to latent heat of vaporization, and if the molar elevation is in boiling point is constant K, then it can be calculated and then replace it by 1000 with 100 in the above mentioned formula. That is going to be the K is equal to 10 kb. 10 kb. Clear? So this is how you need to remember the concepts. Clear? Next comes the depression and freezing. Depression and freezing point. So that also we will learn it. Now till here everyone are clear? Till here everyone are clear? Yes, molecular weight ella ತಿಳಿತಲ್ಲ ಇದು. So ಈಗ next ಹೋಗೋದೇನು? Depression in freezing point. So now let's start with the depression in freezing point. Okay, so ಈಗ almost ಇದನ್ನ ಮುಗಿಸಿದ್ವಿ. Okay, molecular weight of the solute is done. Let's move to the depression and the freezing point. So what happens in the depression in the freezing point is, one second guys. Freezing point is a measure of a temperature for the substances which are having the same solid and liquid forms in equilibrium, also having the same vapor pressure. It's having what? Same vapor pressure also, and it is having a same solid and liquid forms in equilibrium. Okay, and the solid forms of a solution will separate out at a lower temperature. Okay, it will be separating out at a lower temperature because of the lower vapor pressure of the solution. Okay, it will settle down at a lower temperature. Why? Because it is actually because of the lower vapor pressure of the solution. Same way it's happening in this way also. You can check it out in the graph. Vapor pressure versus temperature ಇದೆ, right? So ಇಲ್ಲಿ vapor pressure versus temperature ನಲ್ಲಿ ಇದೇನು T, it is a solution T which is going to be separated here. So how you are going to form the solution? According to the vapor pressure, whenever you are increasing the temperature, vapor pressure is also going to increase, right? So solvent is this much and the solution is going to be this much. Clear? So ಅದ್ರ ಸಲುವಾಗಿ ಯಾವಾಗ ಸಾಲಿಡ್ ಫಾರ್ಮ್ ದಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಸೆಪರೇಟ್ ಔಟ್ ಮಾಡ್ತೇವಲ್ಲ, ಸೆಪರೇಟ್ ಔಟ್ ಯಾವಾಗ ಮಾಡ್ತೇವಲ್ಲ, ಆ ಸೆಪರೇಟ್ ಔಟ್ ಮಾಡಿದಾಗ ಲೋವರ್ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಆಕ್ಚುಲಿ ಮೀನ್ಸ್ ಅಟ್ ಅ ಲೋವರ್ ಟೆಂಪರೇಚರ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಲೋವರ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್, ಬಿಕಾಸ್ ಆಫ್ ದ ಲೋವರ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್. Done everyone? Yes, next let's move. That is going to be, it is the decrease in freezing point of the solvent due to the addition of a non-volatile solute. So due to the addition of a non-volatile solute. Now this is also termed as chromoscopy. Okay, this is also very important. Idr melane KCET question keltare. Aita? Next, depression in freezing point, that is delta TF, that is freezing point of the pure solvent minus freezing point of the solution. Freezing point of the solution and freezing point of the pure solvent. Now, next, it is measured by a Beckmann's thermometer method. Okay, how it is being measured? It is measured in the form of Beckmann's thermometer method and Rasta's method, and even the Rasta's method. Clear? Next, delta TF is equal to KF into M. There the delta TF is equal to KF W divided by MW into 1000 divided by W. Now, M or MW is going to be KF into W. Means KF means what? Proportionality constant, that will be considered as, for the freezing point it will be KF. For the pressure, for the different things, which is going to be the depression constant, it will be D itself. Okay, now KF is into W, weight of the solvent, into 1000 divided by delta TF, that is freezing point, into W. So weight of the solvent, here it is, weight of the solvent, weight of the solute, and molar depression. That's what I said you, molar depression constant or cryptoscopic constant, or else cryptoscopic constant. Clear? If in case the molarity of the solution is 1, then delta TF is equal to KF. Delta TF is equal to KF, and where KF is equal to RT square divided by 1000 LF. RT square divided by 1000 LF. Clear? This is also very important concept. In this also they have asked a lot of questions about the thermometer, how it's actually been measured, and especially they have asked about what is the name, the termed name for the depression, so freezing point, depression of freezing point. So ಆ ತರ questions ಕೇಳಬಹುದು. Done? Next, Want-Hoff's factor. Want-Hoff's factor means what? Certain solutes which undergo dissociation or association in the solution are found to show abnormal molecular mass. It's found to show abnormal molecular mass. Due to this, the colligative property becomes abnormal. So whatever the qualitative property will become, that is going to become abnormal. Okay, that will become abnormal, which can be explained by the Want-Hoff factor. So here I is equal to normal molar mass divided by observed molar mass. So normal molar mass divided by observed molar mass. Normal andre enu, adu madle ಏನು ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿರ್ತೇವಲ್ಲ ಅದರದೆಲ್ಲ ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಅನ್ನ ಹಾಕ್ತೇವೆ. ಸೊ ಅಬ್ಸರ್ವ್ಡ್ ಮೋಲಾರ್ ಮಾಸ್ ಅಂದ್ರೆ ಯಾವಾಗ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತೇವಲ್ಲ, ದಟ್ ಟೈಮ್ ವಾಟ್ ವಿಲ್ ಕಮ್, ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಅಬ್ಸರ್ವ್ಡ್ ಮೋಲಾರ್ ಮಾಸ್. ಕ್ಲಿಯರ್? Next, I is equal to observed colligative property divided by normal colligative property. One more want of factor we have, that is going to be actual number of the particles or the species, means how many number of particles are present, like 2, 3, means n value basically if you tell, okay, divided by accepted number of the particles or species, accepted number of the particles or species. Clear? Next, for solutes showing dissociation, the want-of factor I is actually greater than the L. So, a want-of factor I is greater than the L. For example, Fe3 plus 3Cl minus will give Fe3 plus 3Cl minus. Here, the want-of factor is going to act like a I is equal to 4. Now, how in case want-of factor is going to be 2. In case want-of factor 2 idre, mx, MnO3 and MsO4 will be there, okay, where it is directly proportional to 1, okay, where the directly proportional to 1. If in case want-of factor is 3, then it is going to be this. Want-of factor is going to be 4, then this will be there. Want-of factor 5, then this will be there. Clear? Now, for solutes showing association, the want-of factor I is lesser than the 1, okay. Yav solute ge in. So, if it is showing association, okay, yav solute association ತೋರಿಸ್ತಿದೆಯಲ್ಲ ಅವಕ್ಕೆಲ್ಲ the want of factor is going to be less. Clear? Means what? Association, then it's going to be what? Want of factor, that is I will be lesser than 1. I will be lesser than 1. Done. Now, acids like, example, dimerization of the acids like benzoic acid in the benzene. That is a simple example which we can give it. Now, for the solutes showing neither dissociation nor the association, then the want of factor is going to be I is equal to 1. For example, urea, glucose, sucrose and all, which is not showing dissociation and association. One second. Dissociation, where is our dissociation? Yes. Dissociation and association together if it's showing dissociation and association. If it's not showing dissociation and association, okay, if it's not showing dissociation and association, that time I is actually equal to 1. I is actually equal to 1. Done. This much you should remember about the want of factor. Next, degree of dissociation is actually equal to I minus 1 divided by N minus 1, where N is going to be acting in the form of number of species formed after the dissociation. Dissociation agi mugud takshana enaguttalla, that will be the N value. Clear? N value will be what? When there will be a ಡಿಸೋಸಿಯೇಷನ್ ಆಗಿ ಮುಗ್ದಿರುತ್ತಲ್ಲ ಆ ಟೈಮ್ದಲ್ಲಿ ಅದು ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? ಆ ಟೈಮ್ದಲ್ಲಿ ಅದು ಆಗುತ್ತೆ. ಡನ್. Now, here N is equal to number of the species formed after the association. So, the dissociation adaga, dissociation constant is equal to I minus 1 divided by N minus 1. In the case degree of association is going to be there, that time N minus Y divided by N minus 1. That will be the formula after the, one second, after the association. ಅಂದ್ರೆ ಏನು, ಡಿಸೋಸಿಯೇಷನ್ ಆದಾಗ ಒಂದು ಇರುತ್ತೆ ಮತ್ತೆ ಅಸೋಸಿಯೇಷನ್ ಆದಾಗ ಒಂದು ಇರುತ್ತೆ ವಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್. ಆಯ್ತಾ? ಸೊ ಇನ್ ಸಿಂಪಲ್ ನೋ ಇಷ್ಟು ನೆನಪಿಟ್ಕೋಬಹುದು. ದಿಸ್ ಥಿಂಗ್, ಬೋತ್ ದ ಥಿಂಗ್ಸ್ ಇಫ್ ಯು ರಿಮೆಂಬರ್ ದೆನ್ ಆಲ್ಸೋ ಎನಫ್. ಓಕೆ. Next comes measuring molecular mass of a polymers. So molecular mass of a polymers is best determined by osmotic pressure. So molecular mass is actually of the polymers is actually measured, this of the polymers is best determined by the osmotic pressure. Now, firstly, because the values given by the other colligative properties are so low that they cannot be measured accurately. They cannot be measured accurately. And it can be made at a room temperature and do not require heating, which may change the nature of the polymer. Okay. Nature of the polymer will change if in case, if we are actually, see, we are made at a room temperature, it has been made. But, and do not require heating, which may, if in case you are applying a more heat, or it is like a seasonal wise also, if you are doing it in a summer season where the temperature is more, that time also it might affect the polymer. Clear? Next comes a few questions related to it. Let's discuss few questions. So first is components of a binary mixture of a two liquids A and B were being separated by a distillation. After some time, separation of a components been stopped, and the composition of the vapor phase become the same as that of the liquid phase. Okay, same as that of the liquid phase. That time both the components started coming in the distill. Explain why this happened. So whenever the both components have started coming for the distillation, the liquid and the vapor phase which is there, that will have the same composition. That will have the same composition. Right? So same composition. So this shows that azeotropic mixture, therefore it can be separated by distillation. It can be separated by distillation process. Clear? So this can be separated by distillation process also. Now next, explain why on an addition of a 1 mole of a NaCl to 1 liter of a water. Okay, 1 mole of NaCl to 1 liter of a water, the boiling point of the water will start increasing. Okay, now boiling point will start increasing. Now that time what happens, while the addition of a 1 mole of a methyl alcohol to the 1 liter of the water, the decrease in the boiling point will be present. Decrease in the boiling point will be present. So for that purpose, NaCl is the non-volatile solute. On adding NaCl to water, vapor pressure is lowered and hence boiling point of water will start increasing. So what happens there? The boiling point only will start increasing. No, why? Because NaCl is a non-volatile solute. Okay, non-volatile solute it is. Man, whenever you are adding, NaCl ಹಾಕ್ತಾರಲ್ಲ water vapor ದಲ್ಲಿ, ಆ pressure create, vapor pressure create ಆಗ್ಲಿಕ್ಕೆ start ಆಗುತ್ತೆ, which will lower it, right? Vapor pressure will be lowered, and then what happens? Boiling point of the water will increase. Pressure decrease ಆಗುತ್ತೆ ಹೋದ್ರೆ low temperature increase ಆಗುತ್ತೆ ಹೋಗುತ್ತೆ, right? Methyl alcohol is more volatile than the water. So on adding the methyl alcohol into the water, vapor pressure of the solution is greater. Vapor pressure of the solution is going to be greater than that of the water. Hence boiling point of the water will decrease. Hence the boiling point of the water is going to be increase. Clear? So here what happens? Hence the boiling point of the water will start decreasing. Done? Just 1 minute, guys. So ಇದೇ ತರ ಬಹಳ questions ಕೊಟ್ಟಿದ್ದೇನೆ ನಿಮಗೆ ನಾನು. You can just check it out. These are some questions which I have given you. You can go through these questions also properly. Clear? We have given you people the multiple choice questions also. So those also will be separately, the session will be conducted for the MCQs. MCQs means separately means why? ಏನೇನು ಈಗ ಥಿಯರಿ ಎಲ್ಲ ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೇವಲ್ಲ, ಥಿಯರಿ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ಲಿ ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಅದಾದ ತಕ್ಷಣ ನಾವು ಫುಲ್ PYQ ಕ್ಲಾಸನ್ನು ತೊಗೊಂಡ್ಬಿಡೋಣ, ಆಯ್ತಾ? So now molarity of the H2SO4 is 0.8 and its density is 1.06 grams per centimeter cube. What will be its concentration in terms of the molality and the mole fraction? So here you can just check it out. Molarity of the H2SO4 is how much? 0.8. They have already given it. So it means what? 0.8 mole of H2SO4 are present in 1 liter of solution of 0.8 mole of H2SO4. So that is going to be what? 0.8 into 98 grams. That will be 78.4 grams. So this 1 liter of H2SO4 solution is equal to 1000 into 1.06 grams. That will be 1060 grams. Therefore, the mass of the solvent, that is water, as I told you, how much the more quantity will be, that will be the solvent, right? So water, that is 1060, which we have found it just now. About that, we are going to substitute minus 78.4 grams. The weight means H2SO4 at 0.8 mole of H2SO4, how much it is, that we are going to substitute it. We are going to get the value using one to already calculator allowed irutte PU board nalli, but KCET nalli no allowed irutte, I guess so. So 981.6 divided by 18 moles, that will be how much? 54.53 moles. Same ಅದೇ ತರ ಈಗ we need to find the molality. Okay, molality is equal to 0.8 into 981.6 grams into 1000 kg. Why? Because we are finding the molality. Molality means kg. I told you already. Molarity means it is going to be in the form of a liters. Clear? So in there, how much it will get the answer? 0.815 moles per kg. Done. Further, the solution contains 0.8 mole of solute in 54.53 moles of solvent. 54.53 moles of solvent. Therefore, the mole fraction of the solute is going to be how much? 0.8 divided by 0.8 plus 54.53. That will be 0.014. Done. So this much you should remember. I have given some multiple choice questions also, which you people can concentrate and study them also. Clear? So today is this much is the today's class. Okay, solution chapter in the most probably they will be asking the about the concepts which I have told you. Our chapters in the ashte odi KCET ge bhala important to, like example Raoult's law, like formulas which I told you to practice. Those all things if you practice, no, it's very easy to do it. But usually KCET nalli solution chapter in the ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂದನೇ ಜಾಸ್ತಿ ಬರೋದು ಆಯ್ತಾ. ಸೊ ಡೋಂಟ್ ಗೆಟ್ ಪ್ಯಾನಿಕ್ ದಟ್ ಓನ್ಲಿ ದಿಸ್ ಮೆನಿ ಡೇಸ್ ಆರ್ ರಿಮೈನಿಂಗ್. ನಾ ಹೇಗೆ ಓದ್ಬೇಕು ಮ್ಯಾಮ್, ಭಾಳ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಿದೆ. ಐ ಅಗ್ರಿ ದಟ್ ದಿಸ್ ಮೆನಿ ಡೇಸ್ ಆರ್ ರಿಮೈನಿಂಗ್, ಬಟ್ ಯು ನೀಡ್ ಟು ಬಿ ವೆರಿ ಸ್ಟ್ರಾಂಗ್ ಎನಫ್ ಟು ಮೇಕ್ ಅಪ್ ಯುವರ್ ಮೈಂಡ್ ಆ್ಯಂಡ್ stay strong so that you can finish it, because ನಿಮಗೆ theory ಗೊತ್ತಿದೆ. There is no negative marks in the KCET. There is no headache also that it should negative marks are there, then I should be very careful while attempting the questions. Not like that. And one question carries 1 marks each, so it is also very easy. And even you have an idea about which chapters are there, which chapters in that chapter, which concept is very important. Those all things also you people know. So it's very good if you people will maintain the consistency to prepare it. Okay, so till then, see you everyone. See you in the next class. Bye bye.